Hello there, and welcome. Tonight I want to take you somewhere extraordinary, somewhere that exists in the space between what we know and what we can only imagine. Close your eyes for just a moment if you'd like, or keep them softly open, gazing at wherever you are right now, and let me paint you a picture of something that might not be real in the way we usually think of reality, but perhaps is real in the way that dreams are real, in the way that wonder is real, in the way that the feeling of connection across vast distances is real. Tonight, we're going to explore a question that sounds impossible at first, a question that makes scientists shake their heads and yet there's something about it that tugs at the imagination, that whispers of possibilities we haven't quite grasped yet. What if every star in the universe, every single point of light you see when you look up at the night sky, was connected by invisible bridges? I know how that sounds at first. It sounds like fantasy, like something from a children's story or a dream you might have after falling asleep under the stars, but stay with me here, because sometimes the most profound truths about our universe begin as the wildest imaginings, and sometimes the line between what we call real and what we call impossible is thinner than we think. You see, we live in a cosmos that has already surprised us countless times, a universe that has shown us again and again that reality is stranger, more beautiful, more interconnected than we ever dared to imagine. Black holes that bend time itself, particles that remain mysteriously linked across impossible distances, dark matter that we can't see but know must be there, holding galaxies together like an invisible embrace. So why not bridges between stars? Why not pathways of connection that we simply haven't learned to see yet? Before we drift deeper into this cosmic mystery together, I'm curious about you, about where you are as you listen to these words. Are you lying in bed, perhaps, with the darkness of your room matching the darkness between the stars we're about to explore? Or maybe you're sitting by a window, and if you're lucky, you can actually see a star or two beyond the glass. What time is it where you are? Is it that perfect hour when the world has grown quiet, when the day's concerns have begun to fade, when your mind is ready to wander into gentler territories? I'm speaking to you from this moment, but you're listening from your own unique point in space and time, and isn't that itself a kind of bridge, a connection across the invisible distances between us? If you're finding comfort in these words, if this journey we're beginning together feels like something you'd like to continue, perhaps you might consider subscribing, so we can meet again in this peaceful space between waking and sleeping. And if you'd like, leave a gentle comment telling me where in the world you're listening from. I love knowing that these words are reaching someone in Tokyo at dawn, someone in London at midnight, someone in New York as the evening settles in, someone in Sao Paulo as the afternoon light fades. We're all under the same stars after all, even when we can't see them, even when clouds or sunlight hide them from view. The idea of bridges between stars isn't entirely without precedent in our thinking about the cosmos. Throughout human history, we've imagined connections between the lights in the night sky. Ancient cultures drew constellations, seeing hunters and bears and swans in the arrangement of stars, creating meaning and narrative from what might seem like random scatter. The Aboriginal Australians saw the dark spaces between stars as important as the stars themselves, reading stories in the shadows, understanding that emptiness and fullness are both part of the same cosmic tapestry. The ancient Greeks imagined crystal spheres holding the planets and stars, everything connected in a vast harmonious mechanism. The Vikings spoke of the rainbow bridge, Bifrost, connecting the realms of existence. And now, in our modern age, we speak of wormholes and cosmic strings, of quantum entanglement and dark energy, all different ways of imagining that space isn't empty, that the vast distances between things might not be as vacant as they appear. What if these invisible bridges were real in some way we haven't quite understood yet? Not bridges made of stone or steel, of course, not structures you could walk across or photograph with a telescope, but something subtler, something that exists in dimensions we're only beginning to perceive. Think about how many invisible things we've discovered that our ancestors couldn't have imagined. Radio waves carrying voices across oceans, magnetic fields guiding birds across continents, gravity itself, invisible but undeniable, reaching across the cosmos to choreograph the dance of planets and stars. Each of these discoveries must have seemed impossible until the moment it became obvious, until we developed the eyes to see or the instruments to detect what was always there, waiting patiently for us to notice. When I invite you to imagine bridges between stars, I'm not asking you to abandon scientific thinking or to embrace pure fantasy. Instead, I'm inviting you into that fertile space where imagination and investigation meet, where wonder leads to questions and questions lead to discoveries. Some of the greatest scientific breakthroughs began with someone asking, what if? What if time isn't constant? What if particles can be in two places at once? What if the universe is expanding? What if every star is connected in ways we haven't perceived yet? These questions don't diminish science, they energize it. They remind us that the universe is not a solved puzzle, but an ongoing mystery, and we're all part of the investigation, even in our quietest moments of contemplation. Let's think about what we mean when we say bridge. A bridge is a connection, a way of bringing together what seems separate. It's a structure that allows passage, that creates continuity where there appeared to be division. But bridges don't have to be physical structures. We speak of bridging differences, bridging time, bridging cultures. Music can be a bridge between hearts. Memory can be a bridge between past and present. Dreams can be a bridge between the conscious and unconscious mind. So when we imagine bridges between stars, we're really asking, in what ways might the stars be connected that we haven't recognized yet? What kinds of passages might exist in the cosmic dark? The universe we've discovered through science is already far more connected than it appears to the casual observer. Every atom in your body, every atom in the earth, every atom in everything you've ever touched or seen was forged in the heart of a star. We are literally made of stardust, as Carl Sagan so beautifully reminded us. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of it was created in stellar furnaces billions of years ago, scattered across space when those stars died, gathered together again to form new stars, new planets, and eventually you. In this very real sense, you are connected to every star you see and every star you don't see. The bridges already exist within you, in every cell of your being. But perhaps the connections go even deeper than the physical elements we share with the stars. Consider light itself, the way it travels across incomprehensible distances to reach us. When you look at a star, you're seeing light that left that star years, decades, centuries, millennia ago, depending on how far away it is. That light has travelled through the vacuum of space, maintaining its integrity, carrying information about the star that created it, until it reaches your eye and becomes part of your experience. Isn't that a kind of bridge? A bridge of photons, a bridge of information, a bridge of time itself. You're not seeing the star as it is now, but as it was when that light began its journey. You're connected to the past of that star, and in a sense, that star's past is happening right now in your present moment of observation. The space between stars, which we call the interstellar medium, isn't truly empty either. It's filled with an incredibly thin soup of gas and dust, of magnetic fields and cosmic rays, of particles and waves we're only beginning to understand. The density is so low that by Earth standards it would be considered a perfect vacuum, but across the vast distances of space, even this ethereal material adds up to something significant. Stars aren't isolated islands in an empty void. They exist within this subtle medium, affecting it and being affected by it. Stellar winds from one star push against stellar winds from another. Magnetic fields stretch and twist through space, creating invisible structures that we can only detect with specialized instruments. Gravity reaches out from every star, every planet, every speck of dust, creating an intricate web of attraction that shapes the movement of everything else. When we look at the night sky with our naked eyes, we see perhaps a few thousand stars on the clearest, darkest night. But our galaxy alone contains hundreds of billions of stars, and there are trillions of galaxies in the observable universe. The numbers become meaningless at a certain point, too large for our minds to truly grasp. But what if we think of it differently? What if instead of trying to comprehend the sheer number of stars, we consider the possibility that they're all part of a single, interconnected system? Not separate lights scattered randomly through space, but nodes in a vast network, each one connected to the others through pathways we're only beginning to perceive. Modern physics has already shown us that the universe is far stranger than our everyday experience would suggest. Quantum mechanics tells us that particles can be entangled, maintaining instantaneous connections across any distance. General relativity reveals that space and time are not fixed stages but dynamic, flexible dimensions that can be warped and curved. String theory suggests there might be dimensions beyond the three spatial dimensions and one time dimension we experience. tiny, curled-up dimensions that could harbour all sorts of connections we can't directly perceive. Dark matter and dark energy make up most of the universe, and we don't really know what they are, only that they must exist to explain what we observe. In a universe this strange, this full of hidden dimensions and invisible forces, is it really so impossible to imagine that stars might be connected in ways we haven't discovered yet? Think about how we've understood connections in the past and how that understanding has evolved. Ancient peoples saw the stars as fixed points on a celestial sphere, all equidistant from Earth. Then we learned that stars are at vastly different distances, that what looks like a flat pattern is actually a three-dimensional distribution across space. We thought stars were eternal and unchanging, then we discovered they're born, they live, and they die. We thought space was empty, then we discovered it's full of fields and particles and energy. Each revolution in understanding revealed new types of connections, new relationships between things we thought were separate. Why should we assume we've discovered all the connections that exist? Perhaps these bridges between stars are made of something we don't have a name for yet, something that doesn't interact with light or ordinary matter in ways we can easily detect. Perhaps they exist in those hypothetical extra dimensions, shortcuts through the folded fabric of space-time. Perhaps they're streams of dark matter, rivers of invisible substance flowing between the stars. Perhaps they're more abstract than physical, patterns in the quantum field, correlations in the cosmic background radiation, harmonics in the gravitational waves that ripple through space. The bridges might be right in front of us, all around us, through us, and we simply haven't developed the conceptual framework to recognize them yet. As you lie there or sit there, listening to these words, feeling perhaps the gentle pull of sleep beginning to tug at your consciousness, consider that you might be experiencing one of these bridges right now, not in some mystical or supernatural way, but in the very real sense that consciousness itself might be connected to the cosmos in ways we don't understand. We know that the matter in our brains was forged in stars. We know that the physical laws that govern our thoughts are the same laws that govern the movements of galaxies. We know that we're capable of contemplating the universe, of wondering about our place in it, of feeling awe and curiosity and connection. Is it so strange to imagine that this capacity for wonder might itself be a bridge, a way that the universe becomes aware of itself through us? The gentle rhythm of your breathing as you listen to these words is powered by oxygen that was created in stars and released by plants that capture energy from our own star, the sun. The electrical impulses in your brain that process these ideas follow the same electromagnetic laws that govern the aurora borealis and the radiation from pulsars. The atoms in your body vibrate with the same quantum uncertainties that operate in the hearts of distant suns. You're not separate from the cosmic story. You're woven into it at every level, connected to it through bridges both visible and invisible, known and unknown. When ancient navigators looked up at the stars to find their way across the oceans, they were using the stars as bridges between where they were and where they wanted to be. The stars told them stories of direction and season, of latitude and time. In a sense, they were reading the invisible connections, following pathways written in light across the darkness. We still do this today, though our navigation has become more sophisticated. Our spacecraft use the positions of stars to orient themselves. Our GPS satellites reference stellar positions to maintain their accuracy. We are still following those bridges of light, still using the connections between stars to find our own way. But what if the connections go deeper than navigation, deeper than shared elements, deeper than light and gravity and magnetic fields? What if consciousness itself, the fact that the universe has evolved, creatures capable of contemplating the universe, represents a kind of bridge? We are, after all, the universe looking at itself, thinking about itself, wondering about itself. Through us, stars separated by billions of light years are brought together in thought. When you learn about a distant galaxy, when you see an image captured by a telescope, when you wonder about what might be out there, you're creating connections that transcend physical distance. The bridges might not be made of matter or energy as we understand them, but of something more fundamental, the capacity for one part of the universe to be aware of another part. As we prepare to drift deeper into this cosmic mystery together, to explore what these bridges might be and what they might mean, I want you to remember that we're not trying to prove anything tonight. We're not conducting a rigorous scientific investigation or making claims about the nature of reality. We're doing something gentler, but perhaps equally important, we're wondering. We're allowing our minds to play with possibilities, to float free from the constraints of what we know for certain and explore what might be. This kind of wondering isn't opposed to science. It's often where science begins. Every great discovery started with someone wondering what if, and then following that wonder wherever it led. The stars above you tonight, whether you can see them or not, are not cold, distant lights with no relevance to your life. They are part of your story, and you are part of theirs. The iron in your blood once flowed in stellar cores. The light entering your eyes has travelled for years across space to reach you in this exact moment. The gravity of distant stars, however faint, still reaches you, still includes you in the cosmic dance. And perhaps, just perhaps, there are other connections we haven't discovered yet, bridges we haven't learned to see, pathways that link every star to every other star and to us as well. In the chapters ahead, we'll explore what these bridges might be made of, how they might work, what evidence we might look for, and what it might mean for us if they exist. We'll journey through the latest discoveries in astrophysics and cosmology, but we'll do so with a spirit of gentle curiosity rather than urgent seeking. We'll consider possibilities that stretch our imagination while staying grounded in the wonder of what we already know to be true, and throughout it all, we'll remember that the greatest mystery might not be whether these bridges exist, but why we feel so compelled to look for them, why the idea of cosmic connection resonates so deeply in our hearts. So settle in, dear listener, wherever you are in the world, whatever time of day or night surrounds you. Let your breathing slow and deepen. Let the concerns of the day begin to fade like stars at dawn. We're about to embark on a journey that will take us from the smallest quantum particles to the largest cosmic structures, from the beginning of time to the far future, from the depths of space to the depths of consciousness. And through it all, we'll be following those invisible bridges, those hidden connections, those whispered possibilities that suggest the universe is far more interconnected, far more wonderful than we've ever dared to dream. The stars are waiting for us, patient as always, steady in their courses, keeping their secrets while sharing their light. And perhaps tonight, in the quiet space between waking and sleeping, between knowing and wondering, between the possible and the impossible, we might catch a glimpse of those bridges that connect them all. Perhaps we might even discover that we ourselves are one of those bridges, a living connection between earth and sky, between matter and consciousness, between what is and what might be. The journey begins now, with your next breath, with your next heartbeat, with your next thought reaching out across the darkness toward the light. Now let us zoom out together, slowly, gently, like a camera pulling back from Earth in one of those beautiful sequences you might have seen, where our blue marble of a planet grows smaller and smaller until it's just a point of light, then disappears entirely into the vast darkness punctuated by stars. But we're not going to lose you in that vastness. No, we're going to help you understand your place within it, help you feel how even as the scales become incomprehensible, you remain connected, you remain significant, you remain a vital part of the whole. Because if every star truly is connected by invisible bridges, then you too are part of that network, a node of consciousness in an infinite web of light and connection. Let's begin with something familiar, something human-scaled. Before we expand into the cosmic, imagine you're standing in a great city at night, perhaps on a hill or a tall building, looking out at all the lights spread before you. Each light represents a life, a home, a story unfolding. The streets between them are like bridges, carrying people and cars and buses, carrying conversations and dreams and the stuff of daily life. From your vantage point, you can see how the city is really a network, how every part is connected to every other part through visible roads and invisible relationships. Now, keep that image in your mind, that sense of a vast network of lights and connections, as we lift our perspective higher and higher until cities become spots of light on continents, continents become parts of a sphere, and that sphere becomes a tiny point orbiting a star. Our star, the Sun, is about 93 million miles from Earth, a distance so vast that light itself, the fastest thing in the universe, takes 8 minutes to travel from the Sun's surface to your eyes. If the Sun were to suddenly disappear, which of course it won't, we wouldn't know for 8 minutes, we continue to see its light, feel its warmth, for those 8 minutes while the last rays travelled across space to reach us. That's our first bridge, isn't it? That bridge of light that connects us to our star, that carries energy and information across the vacuum, that makes life on Earth possible. Without that bridge, without that constant flow of photons across 93 million miles of space, our planet would be a frozen, lifeless rock. But our sun is just one star among hundreds of billions in our galaxy, the Milky Way. If you've ever been lucky enough to see the Milky Way on a truly dark night, far from city lights, you know it looks like a river of light flowing across the sky. That river is actually the combined light of billions of stars, so many and so far away that our eyes can't separate them into individual points. We're inside this galaxy, about 2/3 of the way out from the centre, on what we call the Orion Arm, a spiral arm of stars and gas and dust. From our position, we're looking through the disk of the galaxy when we see that river of light. It's like being in a forest and trying to see the shape of the forest itself. We can't step outside to get a better view. We have to piece together our understanding from within. The Milky Way is about 100,000 light-years across. Think about what that means. Light, travelling at 186,000 miles per second, fast enough to circle Earth 7 times in a single second, takes 100,000 years to cross our galaxy. The light from stars on the far side of the galaxy that reaches your eyes tonight left those stars when humans were just beginning to spread across the Earth, when mammoths still walked in the north, when the Sahara was green and lush. You're not just looking across space when you look at the night sky. You're looking back in time, seeing the universe as it was, not as it is. Every star you see is showing you its past, and the farther away it is, the deeper into the past you're seeing. Within our galaxy, stars are not distributed randomly like scattered sand. They follow patterns, they cluster together, they orbit around the galactic centre in vast, slow circles that take hundreds of millions of years to complete. Our Sun and our solar system have made this journey around the galaxy only about 20 times since they formed 4.6 billion years ago. As we make this journey, we pass through different regions of the galaxy, sometimes through these spiral arms, where stars are more densely packed and new stars are being born, sometimes through the quieter spaces between the arms. We're fellow travellers with the stars near us, all following similar orbits, all part of what astronomers call the local standard of rest. Even in the vastness of the galaxy, we have neighbours, fellow stars that have been travelling alongside us for millions of years. The nearest star to our Sun is Proxima Centauri, about 4.2 light-years away. If we could travel at the speed of light, which we can't, it would take 4.2 years to reach it. With our current technology, with the fastest spacecraft we've ever built, it would take tens of thousands of years. Yet even at that immense distance, Proxima Centauri and our Sun are connected. They feel each other's gravity, infinitesimally weak at this distance, but still there, still real. They're moving through the same region of the galaxy, affected by the same galactic tides and gravitational influences. They may have formed from the same giant molecular cloud billions of years ago, making them siblings in a cosmic sense, and light from each star eventually reaches the other, carrying information about temperature and composition, and any planets that might be orbiting. When we talk about the architecture of the cosmos, we're really talking about multiple levels of structure, each nested within the next like Russian dolls. Planets orbit stars. Stars cluster together in groups and associations. These clusters move through galaxies. Galaxies themselves cluster together in groups and superclusters. And at the largest scale we can observe, these superclusters are arranged in what we call the cosmic web, vast filaments of galaxies separated by enormous voids. At every level there are connections, bridges of gravity and light and matter that bind the structures together. Let's think about stellar nurseries, those regions where new stars are born. They're vast clouds of gas and dust, mostly hydrogen, sometimes hundreds of light-years across. Within these clouds, gravity slowly pulls material together, creating denser and denser regions. Eventually, the pressure and temperature in these regions become so intense that nuclear fusion ignites and a new star is born. But here's the beautiful part. Stars are rarely born alone. They're born in clusters, sometimes hundreds or thousands of stars all forming from the same cloud over a period of a few million years. These stellar siblings start their lives connected, orbiting around their common centre of mass, sharing the same chemical composition, the same age, the same origin story. Over time, these star clusters may disperse. Gravitational interactions with other stars and with the galaxy itself can fling cluster members in different directions. Our Sun was probably born in such a cluster, and its siblings are now scattered across the galaxy, too far away for us to identify them with certainty. But they're out there, stars that share our Sun's birthday, stars made from the same cosmic ingredients. If we could trace all their paths backward through time, we'd see them converging, coming together in that stellar nursery where they all began. The bridges that connected them at birth have stretched and attenuated, but perhaps they're not entirely broken. Perhaps there are subtle similarities, shared characteristics, that still link our Sun to its long-lost siblings. The space between stars, as I mentioned earlier, isn't empty. The interstellar medium is like an ocean, albeit an incredibly thin one. In the densest regions, there might be a few hundred atoms per cubic centimetre. For comparison, the air you're breathing contains about 1018 atoms per cubic centimetre, 10 billion times denser. But space is so vast that even this incredibly thin material adds up to enormous amounts. The interstellar medium contains gas, mostly hydrogen and helium, and tiny grains of dust made of carbon, silicon, and other elements. It's threaded through with magnetic fields and crossed by cosmic rays, high-energy particles zipping through space at nearly the speed of light. This interstellar medium isn't uniform. It has structure, patterns, flows, and currents. There are bubbles blown by stellar winds and supernovae, regions where the medium has been swept clear by the pressure of starlight and stellar explosions. There are dense molecular clouds where the medium has collapsed under its own gravity. There are shock waves propagating through space where fast-moving gas collides with slower-moving gas. And there are magnetic fields that channel charged particles along invisible lines, creating paths through space that particles preferentially follow. These structures in the interstellar medium create connections between stars, pathways along which matter and energy flow. Consider the heliosphere, the bubble of space dominated by our Sun's solar wind. This wind, a stream of charged particles flowing outward from the Sun at hundreds of kilometers per second, pushes against the interstellar medium, creating a bubble that extends far beyond the orbit of Pluto. The Voyager spacecraft, launched in 1977, have now crossed the boundary of this bubble and entered interstellar space proper. They're humanity's first ambassadors to the space between the stars, and they're finding that the boundary isn't sharp but gradual, a region where the Sun's influence slowly fades and the influence of other stars and the galaxy itself takes over. Every star has such a bubble, and where these bubbles meet and interact, there are boundaries, transitions, places where the influence of one star gives way to another. Now let's expand our view even further, beyond our local neighbourhood of stars, beyond the spiral arm we inhabit, to see the entire galaxy. The Milky Way is a barred spiral galaxy, with a central bar-shaped structure and spiral arms winding outward. It contains somewhere between 200 and 400 billion stars, along with vast amounts of gas and dust, and all of it is held together by gravity and we believe by dark matter, that mysterious substance we can't see but know must be there. The galaxy rotates, but not like a solid disk. Stars closer to the centre complete their orbits faster than stars farther out, creating a differential rotation that helps maintain the spiral structure. But here's where it gets really interesting. The galaxy isn't just a collection of stars orbiting a common centre, it's a dynamic, evolving system with its own weather, its own seasons, its own life cycle. Spiral arms aren't fixed structures but density waves, regions where stars and gas are temporarily more concentrated as they pass through. Star formation is triggered in these density waves, creating bright, hot, young stars that illuminate the arms and make them visible. The galaxy has a metabolism, consuming gas to make new stars, recycling material through stellar, winds and supernova, gradually converting hydrogen into heavier elements. And our galaxy doesn't exist in isolation. It has companion galaxies, smaller galaxies that orbit around it like moons around a planet. The large and small Magellanic Clouds, visible from the southern hemisphere, are two such companions. They're connected to the Milky Way by streams of gas, bridges of material that have been pulled out by gravitational interactions. The Milky Way is slowly consuming some of these smaller galaxies, pulling them apart and incorporating their stars into its own structure. We can see the remnants of past galactic meals, Streams of stars that once belonged to other galaxies now stretched out in long arcs through our galaxy's halo. Beyond our local group of galaxies, the universe continues its hierarchical structure. Galaxies cluster together in groups, groups cluster into superclusters, and superclusters are arranged in the cosmic web. This web is one of the most magnificent structures we've discovered in the universe. Galaxies and galaxy clusters are arranged along filaments, vast threads of matter that can be hundreds of millions of light-years long. Between these filaments are voids, regions with very few galaxies like bubbles in cosmic foam. The entire observable universe has this foam-like structure, with matter concentrated in sheets and filaments surrounding relatively empty voids. The cosmic web isn't just a random arrangement. It formed through the interaction of gravity and the expansion of the universe, growing from tiny quantum fluctuations in the early universe into the vast structures we see today. Dark matter played a crucial role, providing the gravitational scaffolding around which ordinary matter could collect. The filaments of the cosmic web are like cosmic highways, channels along which galaxies can move and interact. Where filaments meet, we often find massive galaxy clusters, the largest gravitationally bound structures in the universe. When we observe distant galaxies, we're seeing them as they were billions of years ago when the universe was younger. We can see galaxies in the process of forming, galaxies colliding and merging, galaxies being born and dying. We're looking at the history of the universe, seeing how structures formed and evolved over cosmic time. And in all of this vast panorama of space and time, we see connections everywhere. Gravity reaches across the void, binding galaxies together. Light carries information from one side of the universe to the other. Matter flows along the filaments of the cosmic web. Even in the vastest scales we can observe, nothing exists in true isolation. But what about dark matter and dark energy, those mysterious components that make up most of the universe? Dark matter, which makes up about 27% of the universe, doesn't interact with light, which is why we call it dark. We can't see it directly, but we can see its gravitational effects. Galaxies rotate too fast to be held together by the gravity of the visible matter alone. Galaxy clusters have more gravity than can be accounted for by the galaxies we can see. Gravitational lensing, the bending of light by gravity, reveals mass where no visible matter exists. Dark matter is there, shaping the universe, providing invisible bridges of gravity that connect structures across space. Dark energy is even more mysterious. Making up about 68% of the universe, it's causing the expansion of the universe to accelerate. We don't know what it is, only that it acts like a kind of anti-gravity, pushing things apart rather than pulling them together. Yet even dark energy might be thought of as a kind of connection, a property of space itself that links every point in the universe to every other point. It's the same everywhere, as far as we can tell, a universal property that affects everything equally. When we consider the architecture of the cosmos, we also have to consider time. The universe is about 13.8 billion years old, and during that time it has evolved from a hot, dense, nearly uniform state to the complex structured cosmos we see today. The first stars formed about 100 million years after the Big Bang, lighting up the universe for the first time. These first stars were massive and short-lived, and when they died in spectacular supernovae, they seeded space with the first heavy elements. The next generation of stars formed from gas enriched with these elements, and the process continued, each generation of stars adding more complexity to the cosmic mixture. We are products of this cosmic evolution. The atoms in our bodies were forged in stars that lived and died before our sun was born. We're made of cosmic history, assembled from elements that have been on incredible journeys through space and time. The carbon in our cells might have been part of a planet orbiting another star billions of years ago. The oxygen we breathe might have been blasted into space by a supernova in a distant galaxy. We're walking, thinking collections of cosmic bridges, temporary arrangements of matter that has been and will be part of countless other structures over the eons. As you contemplate these vast scales of space and time, it's natural to feel small, perhaps even insignificant. The universe is so vast, so old, so complex, and we are so tiny, so brief, so limited in our perception. But consider this. You are the universe becoming aware of itself. Your consciousness, your ability to contemplate these cosmic scales, is not separate from the universe but part of it. Through you, the universe observes itself, thinks about itself, wonders about itself. You are a bridge between the cosmic and the personal, between the vast and the intimate, between matter and meaning. Every atom in your body is connected to the cosmos through an unbroken chain of cause and effect stretching back to the Big Bang. Every thought you think is powered by energy that originated in the sun, which got its energy from nuclear fusion, which is possible because of the fundamental forces that govern the universe. You're not a separate entity observing the universe from outside. You're a pattern of matter and energy that the universe has arranged into a form capable of contemplation. In a very real sense, when you wonder about the stars, it's the universe wondering about itself. The architecture of the cosmos, then, is not just about the physical arrangement of matter and energy in space. It's also about the emergence of complexity, the development of structures capable of processing information, the evolution of consciousness. From the first quantum fluctuations in the early universe to the formation of atoms, from the birth of stars to the origin of life, from the first living cells to conscious beings capable of science and art and wonder, there's been an unbroken chain of development, a continuous unfolding of potential. We are part of that unfolding, participants in the ongoing creation of cosmic architecture. As we float here together in contemplation of these cosmic scales, remember that every level of structure we've discussed is connected to every other level. Quantum particles combine to form atoms, atoms combine to form molecules, molecules combine to form dust grains and gas clouds, clouds collapse to form stars and planets, planets can develop life, life can develop consciousness, and consciousness can contemplate the cosmos. It's all one continuous interconnected system, with bridges operating at every scale, from the subatomic to the supergalactic. The invisible bridges between stars that we're imagining might operate at any or all of these scales. They might be quantum entanglements, maintaining instantaneous correlations across light years. They might be streams of dark matter, invisible rivers flowing through space. They might be patterns in the cosmic web, channels along which influence and information flow. They might be something we haven't discovered yet, some aspect of reality that our current theories don't predict. Or they might be all of these things and more, multiple types of bridges operating simultaneously, creating a cosmos far more interconnected than we currently understand. Now, we arrive at the heart of our contemplation, the gentle turning over of this idea like a smooth stone in our hands, examining it from every angle in the soft light of imagination and possibility. What exactly could an invisible bridge between stars be? Not in the sense of a physical structure we could photograph or walk across, but something more subtle, more fundamental, perhaps more beautiful than any bridge we've built on Earth. Let's explore this question slowly, patiently, the way scientists explore the unknown, but also the way poets explore meaning, the way children explore a garden, with wonder and openness to whatever we might discover. When we say bridge, we're using a metaphor, aren't we? We're taking something familiar from our human experience and applying it to the cosmos, trying to understand the vast through the lens of the intimate. But metaphors can be powerful tools for understanding, especially when we're dealing with concepts that push the boundaries of our normal experience. So let's embrace this metaphor fully, while remaining aware that what we're really talking about might be something far stranger and more wonderful than any bridge we've encountered before. The first kind of bridge we might imagine is gravitational. Gravity is already a bridge of sorts, an invisible connection between masses that reaches across empty space. Every star, every planet, every grain of dust in the universe generates a gravitational field that extends infinitely outward, growing weaker with distance but never quite reaching zero. In principle, every particle in the universe feels the gravitational pull of every other particle, no matter how far apart they are. It's an incredibly weak force at cosmic distances, but it's there, a whisper of connection across the void. But perhaps there's more to gravitational bridges than we currently understand. Einstein showed us that gravity isn't really a force in the traditional sense, but a curvature of space-time itself. Mass and energy bend the fabric of space and time, and objects follow the curves, like marbles rolling on a stretched rubber sheet. What if stars create more complex patterns in space-time than we realize? What if their gravitational fields interact in ways that create channels or pathways through space, routes along which matter and energy preferentially flow? We know that galaxies can create gravitational lenses, bending light around them. Perhaps stars create more subtle lensing effects, focusing not just light but other forms of energy and information in ways we haven't detected yet. Consider the concept of gravitational resonance. In our solar system, planets can fall into resonant orbits, where their orbital periods form simple ratios. Jupiter's moons Io, Europa and Ganymede are in a 1.24 resonance, completing orbits in a synchronized dance. Perhaps stars in our galaxy experience similar resonances, their movements synchronized over millions of years, creating patterns and connections that we haven't recognized because we haven't been watching long enough. These resonances could create gravitational bridges, stable pathways through space that persist over cosmic time. Then there's the possibility of magnetic bridges. Many stars, including our Sun, have magnetic fields that extend far into space. The Sun's magnetic field reaches well beyond the orbit of Pluto, carried by the solar wind. These magnetic fields aren't static. They twist and writhe. They strengthen and weaken. They interact with the magnetic fields of planets and with the galactic magnetic field. Charged particles follow these magnetic field lines like cars on invisible highways, spiraling along them as they travel through space. The galaxy itself has a magnetic field, probably generated by the movement of charged particles in the interstellar medium. This galactic field is weak by Earth standards, about 1,000,000 times weaker than Earth's magnetic field, but it extends across thousands of light years. It channels cosmic rays, affects the formation of stars, and might create connections between stellar systems that we're only beginning to understand. Imagine magnetic field lines stretching between stars like power lines, not carrying electricity in the conventional sense, but perhaps carrying something more subtle, information, influence, or forms of energy we haven't learned to detect. What about bridges made of particles? Space is full of particles we can barely detect. Neutrinos, cosmic rays, and possibly dark matter particles. Neutrinos are particularly interesting because they interact so weakly with ordinary matter that they can pass through entire planets without being affected. Trillions of neutrinos from the Sun pass through your body every second, and you never notice. They travel at nearly the speed of light, carrying information about the nuclear processes in stellar cores. Could streams of neutrinos create connections between stars, rivers of particles flowing through space, largely invisible to us, but perhaps creating subtle influences we haven't recognized? Cosmic rays are another form of particle bridge. These are atomic nuclei, mostly protons, accelerated to incredible energies by supernova, black holes, and other cosmic accelerators. They stream through space in all directions, and when they strike Earth's atmosphere, they create showers of secondary particles. Some cosmic rays have energies far beyond anything we can create in our particle accelerators, and we don't fully understand how they achieve such energies. Perhaps the acceleration mechanisms involve connections between multiple stars, collaborative processes that we haven't imagined yet. And then there's dark matter, that mysterious substance that makes up most of the matter in the universe. We know it's there because we can see its gravitational effects, but we don't know what it's made of. It doesn't interact with electromagnetic radiation, which is why we call it dark. But perhaps it interacts in other ways we haven't discovered yet. Perhaps dark matter forms structures we can't see, bridges and filaments connecting stars and galaxies. Perhaps what we perceive as empty space is actually full of dark matter architecture, an invisible scaffolding that shapes the visible universe. Let's think about quantum bridges for a moment. Quantum mechanics, the physics of the very small, has shown us that reality at the smallest scales is far stranger than our everyday experience suggests. Particles can be in multiple states simultaneously until observed. They can tunnel through barriers that classical physics says should be impenetrable, and most mysteriously, they can be entangled, maintaining instantaneous correlations regardless of the distance between them. When two particles are entangled, measuring one immediately affects the other, even if they're on opposite sides of the universe. Could quantum entanglement create bridges between stars? It seems unlikely with our current understanding because entanglement is fragile and easily broken by interaction with the environment. But perhaps there are forms of entanglement we haven't discovered yet, more robust connections that can survive the journey through interstellar space. Perhaps stars themselves, or particles within stars, can become entangled during formation, or through some process we haven't observed. The bridges might not carry information in the classical sense, but they might create correlations, patterns, connections that shape the evolution of stellar systems in subtle ways. There's also the possibility of bridges through higher dimensions. String theory and other attempts to unify quantum mechanics and general relativity suggest that space might have more than 3 dimensions. These extra dimensions would be tiny, curled up so small we can't perceive them directly. But perhaps connections through these dimensions could link distant points in our 3-dimensional space. Imagine space as a piece of paper. 2 points on opposite edges of the paper seem far apart if you have to travel across the surface. But if you fold the paper, the points can touch. Higher dimensions might allow similar shortcuts, bridges that connect stars through dimensions we can't directly perceive. Wormholes are another theoretical possibility, shortcuts through space-time that could connect distant regions of the universe. While we have no evidence that wormholes actually exist, they're allowed by the mathematics of general relativity. If they do exist, they might be microscopic, far too small for anything macroscopic to pass through. But perhaps information could traverse these tiny wormholes, creating communication channels between stars. Or perhaps the wormholes themselves are dynamic, opening and closing, creating temporary bridges that appear and disappear over cosmic time. Let's consider bridges made of light and electromagnetic radiation. Every star is constantly broadcasting across the electromagnetic spectrum, from radio waves to gamma rays. This radiation carries information about the star's temperature, composition, magnetic field, rotation rate, and any planets that might be orbiting it. When this radiation reaches another star system, it becomes part of that system's electromagnetic environment. Perhaps stars respond to the radiation from other stars in ways we haven't recognized, adjusting their own emissions in response, creating a kind of cosmic conversation we haven't learned to interpret. The cosmic microwave background radiation, the afterglow of the Big Bang, fills all of space with a faint whisper of microwaves. This radiation has been traveling through space for 13.8 billion years, and it carries information about the early universe, but it's also been modified by its journey, affected by the matter it has passed through and around. Perhaps stars leave subtle imprints on this background radiation, markers of their presence that propagate through space, creating connections across vast distances and deep time. What about bridges of information? In our modern world, we're familiar with information traveling through cables and wireless signals, connecting distant points instantaneously. Perhaps the universe has its own information networks, ways that data about one part of the cosmos is transmitted to other parts. This information might not travel through conventional channels, but through the structure of space-time itself, encoded in gravitational waves or quantum fields or aspects of reality we haven't discovered yet. Gravitational waves, ripples in space-time caused by accelerating masses, are a newly confirmed form of cosmic bridge. First directly detected in 2015, these waves carry information about violent cosmic events like colliding black holes and neutron stars, but perhaps all accelerating masses, including orbiting stars, generate gravitational waves, albeit much weaker ones. These waves propagate at the speed of light, carrying information about their sources across the universe. The universe might be filled with a symphony of gravitational waves, a constant exchange of information between all massive objects. Consider also the possibility of bridges through time. We tend to think of bridges as connecting different points in space, but what if they also connect different points in time? Light from stars already does this in a sense, carrying information from the past to the present. But perhaps there are more complex temporal connections, influences that propagate not just forward in time but in more intricate patterns. The block universe concept in physics suggests that all moments in time exist simultaneously, like frames in a film. If this is true, then connections between stars might extend through time as well as space, creating 4-dimensional bridges we can only perceive in cross-section. Plasma bridges are another possibility. Most of the visible matter in the universe is in the form of plasma, gas so hot that electrons have been stripped from atoms. Stars are balls of plasma, and they eject plasma in stellar winds and coronal mass ejections. The interstellar medium contains plasma, and electric currents can flow through this plasma, creating what plasma physicists call Birkeland currents. These currents can be enormous, stretching across light years, carrying electrical energy through space. Perhaps these plasma currents create bridges between stars, channels along which energy and charged particles flow. The concept of morphic fields, proposed by biologist Rupert Sheldrake, suggests that there might be fields that carry information about form and behaviour. While this idea is controversial and not accepted by mainstream science, It represents the kind of creative thinking that sometimes leads to breakthroughs. What if stars generate fields we haven't discovered yet? Fields that carry information about stellar processes and that influence the development of other stars? These fields might not be electromagnetic or gravitational, but something entirely new, a fifth fundamental force or a property of space we haven't recognized. We should also consider the possibility that bridges between stars are not made of any single thing, but are composite structures, combinations of multiple types of connections working together. Just as a bridge on Earth might be made of steel and concrete and cables, all working together to create a stable structure, cosmic bridges might involve gravity and magnetism and particle flows and quantum effects, all interacting in complex ways. The bridge might not be a thing but a process, a dynamic interaction that maintains connections between stars. Perhaps these bridges are emergent phenomena, arising from the complex interactions of simpler components. In the same way that consciousness seems to emerge from the complex interactions of neurons in the brain, cosmic bridges might emerge from the interactions of fields and particles and forces in space. They might not be reducible to any single component, but exist only in the totality of the interactions. This would make them difficult to detect because we tend to study individual phenomena in isolation rather than looking at the system as a whole. The bridges might also be probabilistic rather than deterministic. Quantum mechanics has taught us that at the smallest scales, reality is probabilistic. Particles don't have definite positions and momenta, but probability distributions. Perhaps bridges between stars are similar. Not fixed structures, but probability fields, regions where connections are more likely to form. These probabilistic bridges might fluctuate, strengthening and weakening, appearing and disappearing, creating a dynamic network that's constantly changing, yet maintains certain statistical properties over time. What if consciousness itself is part of these bridges? This is a deeply speculative idea, but worth considering in our exploration. If consciousness is a fundamental property of the universe, as some philosophers and physicists have suggested, then perhaps it creates connections between conscious beings regardless of distance. We are conscious beings made of star stuff, contemplating stars. Perhaps our consciousness creates bridges to the cosmos, connections that operate outside the normal channels of physics. This doesn't mean stars are conscious in the way we are, but perhaps consciousness at our level creates resonances with whatever organizational principles operate at stellar scales. As we contemplate all these possibilities for what invisible bridges between stars might be, it's important to remember that we're not trying to prove anything or claim definitive knowledge. We're exploring, wondering, allowing our minds to play with possibilities. The history of science is full of discoveries that seemed impossible until they were proven true. Electromagnetic radiation was invisible and undetected until we developed the tools to perceive it. Dark matter and dark energy were unknown until their effects became undeniable. Perhaps bridges between stars are waiting for us to develop the concepts and instruments needed to perceive them. The bridges might be right in front of us, hidden in plain sight in data we've already collected but haven't known how to interpret. They might be in the correlations between stellar movements we haven't noticed, in the patterns of stellar formation we haven't recognized, in the synchronicities between distant cosmic events we haven't connected. Sometimes discovery isn't about finding something new, but about seeing what's always been there in a new way. As you drift deeper into contemplation of these possibilities, feeling perhaps the gentle tug of sleep beginning to blur the boundaries between waking and dreaming, consider that the bridge you're crossing right now from consciousness to unconsciousness, from day to night, from known to unknown, might itself be a metaphor for the cosmic bridges we're imagining. Your mind creates connections between disparate ideas, builds bridges between concepts, links memories and imaginings in ways that create new understanding. Perhaps the universe does something similar on a vast scale, creating connections between stars that are less like physical structures and more like thoughts, patterns of relationship and meaning that exist in the fabric of reality itself. The question, what could an invisible bridge be, opens up so many possibilities, so many directions for wonder and investigation. And perhaps that's the most important bridge of all, the bridge between question and possibility, between what we know and what we might discover, between the universe as we understand it and the universe as it actually is, waiting patiently for us to develop the eyes to see, the minds to comprehend, and the hearts to appreciate its full connectivity and wonder. And now, we drift into the spaces between stars, into that vast ocean we call the interstellar medium, where the evidence for connection becomes more tangible, more measurable, yet somehow even more mysterious. Here, in what was once thought to be pure emptiness, we find a rich tapestry of fields and particles, waves and currents, all creating a complex network of interaction that might just be the physical foundation for our imagined bridges. Let's explore this realm together, slowly, gently, like deep-sea divers descending into an ocean that's dark yet full of unexpected light, empty yet teeming with invisible activity. The interstellar medium is perhaps the most misunderstood region of space. For centuries we believed the space between stars was a perfect vacuum, absolutely empty, a void separating islands of matter. But as our instruments became more sensitive, as our understanding deepened, we discovered that this supposed void is actually a sea, albeit the thinnest sea imaginable. If you could take a cubic centimetre of this interstellar ocean, a space about the size of a sugar cube, you would find perhaps 1 or 2 atoms floating within it. For comparison, that same volume of the air you're breathing contains about 10 billion atoms. The interstellar medium is emptier than the best vacuum we can create on Earth. Yet when you multiply that tiny density by the vast volumes of interstellar space, you get enormous amounts of matter, enough to form all the future generations of stars. This cosmic sea isn't uniform, it has weather patterns, currents, waves and tides. There are regions where the medium is compressed, where dozens or even hundreds of atoms crowd into each cubic centimetre. These are the molecular clouds, the stellar nurseries where new stars are born. There are regions where the medium has been blown clear by stellar winds and supernovae, creating bubbles of even more rarefied space. There are shock waves propagating through the medium where fast-moving gas collides with slower gas, heating it to millions of degrees. And threading through it all are magnetic fields, invisible to our eyes but revealed by their effects on light and charged particles. Let's begin with gravity, that most familiar yet most mysterious of forces. Every atom in the interstellar medium, every grain of dust, every molecule of gas generates a gravitational field. These fields are incredibly weak, but they extend infinitely, diminishing with distance but never quite reaching zero. The combined gravitational field of all the matter in the interstellar medium helps hold our galaxy together, contributing to the overall gravitational potential that keeps stars in their orbits. It's like an invisible web, with every particle connected to every other particle through gravitational attraction. But gravity in the interstellar medium does more than just attract. It creates patterns, structures, flows. Where the medium is slightly denser, gravity pulls in more matter, making it denser still. This is how molecular clouds form, through a process called gravitational instability. Small variations in density, perhaps caused by a passing star or a distant supernova's shockwave, can trigger a cascade of gravitational collapse that eventually leads to star formation. These gravitational cascades can propagate through the interstellar medium like slow-motion avalanches, creating chains of star formation that stretch across hundreds of light years. The Gaia spacecraft, launched by the European Space Agency in 2013, has been mapping the positions and movements of over 1 billion stars in our galaxy with unprecedented precision. This data has revealed streams and structures we never knew existed, rivers of stars flowing through space, all following the gravitational currents of the galaxy. Some of these streams are the remnants of smaller galaxies that have been torn apart by the Milky Way's gravity. Others are groups of stars that form together and are still travelling together billions of years later. These stellar streams are like fossil evidence of gravitational bridges, showing us how gravity connects stars across vast distances and deep time. Light, too, creates bridges through the interstellar medium. Every photon that travels from one star to another carries information: the temperature of the star that emitted it, the elements present in that star's atmosphere, the star's rotation rate, its magnetic field strength, and more. This information is encoded in the wavelength of the light, in its polarization, in subtle variations in intensity. When this light passes through the interstellar medium, it's modified further. Dust grains absorb and scatter certain wavelengths, gas clouds imprint their own spectral signatures, magnetic fields rotate the polarization of the light. By the time starlight reaches us, it carries information not just about the star that emitted it, but about everything it encountered on its journey. The interstellar medium is largely transparent to most wavelengths of light, but it's not perfectly transparent. Dust grains, tiny particles of carbon, silicon and other elements, scatter and absorb light, particularly blue light. This is why distant stars appear redder than they actually are. Their blue light scattered away during the long journey through space. These dust grains are incredibly small, typically less than a micrometer across, smaller than the wavelength of visible light. Yet they're numerous enough to significantly affect the light passing through space, creating a kind of cosmic fog that dims and reddens distant stars. But dust grains do more than just scatter light. They're chemical factories, surfaces where atoms and molecules can meet and react. In the cold of interstellar space, many chemical reactions that would be impossible on Earth can occur on the surfaces of dust grains. Water, methanol, formaldehyde, and even more complex organic molecules form on these tiny particles. When dust grains are incorporated into forming planetary systems, they bring these molecules with them, perhaps seeding planets with the chemical precursors of life. In this way, dust grains are bridges not just of light but of chemistry, carrying the products of stellar nucleosynthesis and interstellar chemistry from one stellar system to another. Magnetic fields pervade the interstellar medium, invisible threads that guide the movement of charged particles and shape the formation of stars. These fields are weak by terrestrial standards, typically about a millionth of Earth's magnetic field strength, but they extend across vast distances and play crucial roles in many cosmic processes. Charged particles, which make up a significant fraction of the interstellar medium, are forced to follow these magnetic field lines, spiraling around them as they travel through space. This creates channels, highways through space, along which charged particles preferentially flow. The Voyager spacecraft, humanity's most distant ambassadors, have given us direct measurements of the interstellar medium. Voyager 1 crossed into interstellar space in 2012, and Voyager 2 followed in 2018. They've found that the boundary between our sun's sphere of influence and interstellar space isn't sharp but gradual, a region called the heliosheath, where the solar wind slows down and becomes turbulent as it encounters the interstellar medium. The Voyagers have detected unexpected structures in this boundary region, including a kind of magnetic highway where charged particles from inside and outside the solar system can more easily cross. This discovery suggests that the boundaries between stellar systems aren't walls, but more like permeable membranes, allowing certain types of exchange while restricting others. The interstellar medium also carries sound waves, though not sound as we usually think of it. These are pressure waves, variations in density that propagate through the thin gas. They travel much more slowly than light, typically at speeds of a few kilometers per second, taking millions of years to cross interstellar distances. But they're important for star formation, as they can trigger gravitational collapse in molecular clouds. A pressure wave from a distant supernova, arriving millions of years after the light from the explosion, can compress a cloud enough to start the formation of new stars. In this way, the death of one star can trigger the birth of others, a bridge across time and space mediated by these slow pressure waves. Cosmic rays are another component of the interstellar medium, high-energy particles, mostly protons, that zip through space at speeds approaching the speed of light. They're accelerated by supernova, by black holes, by processes we don't fully understand. These particles carry enormous amounts of energy, and when they strike atoms in the interstellar medium or in planetary atmospheres, they can trigger nuclear reactions, creating new isotopes and generating cascades of secondary particles. Cosmic rays are like messengers from distant catastrophes, carrying information about the most violent events in the galaxy. But cosmic rays don't travel in straight lines. The magnetic fields in the interstellar medium deflect them, causing them to follow complicated, twisted paths through space. A cosmic ray particle might take millions of years to travel a distance that light would cover in thousands of years, bouncing back and forth between magnetic irregularities like a ball in a pinball machine. This means that when we detect cosmic rays, we can't tell exactly where they came from. They've been scrambled by their journey through the galactic magnetic field. Yet, this scrambling itself tells us about the structure of the magnetic field, about the invisible architecture of the interstellar medium. The interstellar medium isn't static. It flows and churns, driven by stellar winds, supernovae, and the rotation of the galaxy itself. There are vast circulation patterns like ocean currents but operating on scales of hundreds of light years and timescales of millions of years. Hot gas rises above and below the galactic disk, cools, and falls back down, creating what astronomers call the galactic fountain. This circulation mixes elements produced by stars throughout the galaxy, ensuring that the products of stellar nucleosynthesis are distributed widely rather than remaining locked in their birthplaces. Stellar winds, streams of charged particles flowing outward from stars, create bubbles in the interstellar medium. Our sun's wind creates the heliosphere, but every star creates a similar bubble. Where these bubbles meet, there are boundaries, regions of interaction where material from different stars mixes and interacts. These boundaries aren't fixed but move as stars move through space, as stellar winds strengthen and weaken, as the density of the surrounding interstellar medium changes. The galaxy is full of these interacting bubbles, a foam of stellar influence that creates a complex, ever-changing pattern of connection and separation. Supernovae, the explosive deaths of massive stars, are perhaps the most dramatic bridges in the interstellar medium. When a star explodes, it releases as much energy in a few seconds as our sun will produce in its entire 10 billion-year lifetime. This explosion sends shock waves racing through space at thousands of kilometers per second, compressing and heating the interstellar medium, triggering star formation, accelerating cosmic rays. The explosion also disperses the elements forged in the star's core, and during the explosion itself, seeding space with carbon, oxygen, iron, and all the other elements necessary for planets and life. The remnants of supernovae can be detected thousands of years after the explosion. The Crab Nebula, for example, is the remnant of a supernova observed by Chinese astronomers in 1054 CE. Nearly 1,000 years later, the nebula is still expanding, still glowing, still affecting the interstellar medium around it. The shockwave from the explosion has travelled about 10 light years, compressing gas, accelerating particles, creating a bubble of hot gas that will continue expanding for thousands of years more. This is a bridge through time, the influence of a star that died a millennium ago still shaping the cosmic environment today. Radio waves provide another window into the interstellar medium. Hydrogen, the most abundant element in the universe, emits radio waves at a specific wavelength, 21 centimeters. This emission comes from a quantum mechanical transition in the hydrogen atom, a flip in the spin of its electron that happens, spontaneously but rarely, about once every 10 million years for any given atom. But there are so many hydrogen atoms in space that this 21 centimeter radiation is constantly being emitted, creating a radio glow that fills the galaxy. By observing this radiation, astronomers can map the distribution and movement of hydrogen throughout the galaxy, seeing structures and patterns invisible in optical light. Other molecules in the interstellar medium emit at different radio wavelengths. Over 200 different molecules have been detected in space, from simple ones like water and ammonia to complex organic molecules with dozens of atoms. Each molecule has its own spectral signature, its own set of wavelengths at which it emits or absorbs radiation. By observing these signatures, astronomers can determine not just what molecules are present, but their temperature, density, and velocity. It's like listening to a cosmic symphony, where each molecule plays its own unique note. The ALMA telescope array in Chile's Atacama Desert has revolutionized our understanding of the molecular interstellar medium. With its 66 radio dishes working in concert, ALMA can see details in molecular clouds that were invisible to previous telescopes. It has revealed that what appeared to be simple, uniform clouds are actually incredibly complex, with filaments, cores, shells, and streams all nested within each other. These structures show us that the interstellar medium is far more organized than we once thought, with matter flowing along preferred paths, collecting in specific regions, forming patterns that might represent the physical manifestation of our imagined bridges. The Parker Solar Probe, launched in 2018, is studying our sun's immediate environment, but its findings have implications for understanding stellar winds throughout the galaxy. It has discovered that the solar wind is far more complex than we imagined, with sudden reversals in magnetic field direction, unexpected variations in speed and density, and structures we're still trying to understand. If our sun's wind is this complex, imagine the complexity of the winds from other types of stars, the fierce winds from hot, massive stars, the variable winds from pulsating stars, the magnetically channeled winds from stars with strong magnetic fields. All these winds interact in the interstellar medium, creating a constantly changing pattern of flows and boundaries. X-ray observations have revealed another component of the interstellar medium: extremely hot gas, heated to millions of degrees by supernova explosions and stellar winds. This hot gas fills much of the volume of the galaxy, creating a network of interconnected bubbles and tunnels. The Chandra X-ray Observatory and XMM Newton have mapped this hot gas, showing that our solar system sits inside one of these bubbles, called the local bubble, about 300 light-years across. This bubble was probably created by a series of supernovae that exploded nearby in cosmic terms over the past 10 to 20 million years. We're living inside the aftermath of stellar explosions, surrounded by million-degree gas that's so thin we don't even notice it. Infrared observations reveal yet another aspect of the interstellar medium. Dust grains, warmed by starlight, emit infrared radiation. The Spitzer Space Telescope and the Herschel Space Observatory have mapped this infrared emission, revealing structures invisible in optical light. They've shown us stellar nurseries hidden inside dark clouds, nascent stars still wrapped in their birth cocoons, jets of material shooting out from forming stars. Infrared light penetrates dust much better than visible light, allowing us to see through the cosmic fog and observe processes hidden from optical telescopes. The interstellar medium also contains exotic particles we're only beginning to understand. Neutrinos, those ghostly particles that barely interact with matter, stream through space in enormous numbers. Every second, about 65 billion neutrinos from the Sun pass through every square centimetre of Earth. Neutrinos from other stars, from supernova, from cosmic ray interactions add to this flux. We're bathed in a sea of neutrinos, particles that carry information about nuclear processes in stars, but are almost impossible to detect. The IceCube Neutrino Observatory at the South Pole uses a cubic kilometre of Antarctic ice as a detector, and even this enormous instrument detects only a handful of cosmic neutrinos each year. Dark matter, if it exists in the form of particles, must also be present in the interstellar medium. We can't detect it directly, but if our theories are correct, streams of dark matter particles are constantly flowing through space, through Earth, through our bodies. These particles would create another layer of connection between stars, an invisible scaffolding that shapes the visible universe through its gravitational effects. Some theories suggest that dark matter might occasionally interact with ordinary matter in ways other than gravity, creating signals we could potentially detect. Several experiments deep underground are searching for these signals, trying to catch dark matter in the act of interaction. As we contemplate all these components of the interstellar medium, all these different forms of matter and energy flowing through space, we begin to see that the space between stars is not empty at all, but full of activity, full of connections, full of bridges. Every star influences its surroundings through gravity, light, stellar winds, and when it dies, through supernova explosions. These influences propagate through the interstellar medium, affecting other stars, triggering new star formation, shaping the evolution of the galaxy. The interstellar medium is the connective tissue of the galaxy, the substrate through which stellar influences propagate, the medium that makes stellar bridges possible. Consider how a message might travel through these various channels from one star to another. A change in one star, perhaps a flare, or a change in its stellar wind would propagate outward in multiple ways. Light carrying information about the change would race outward at 300,000 kilometers per second. The stellar wind itself would follow, traveling at hundreds of kilometers per second. Changes in the magnetic field would propagate at the Alfvén speed, typically tens of kilometers per second in the interstellar medium. Pressure waves would move even more slowly. Each of these signals would be modified by its journey through the interstellar medium, scattered by dust, deflected by magnetic fields, slowed by interactions with the ambient gas. By the time they reached another star, they would carry information not just about their origin, but about everything they encountered along the way. The James Webb Space Telescope, with its unprecedented infrared sensitivity, is revealing new details about the interstellar medium and its role in star and planet formation. It's showing us that the process of star formation is even more complex than we thought, with material flowing in and out, jets and winds shaping the surrounding medium, planets forming even as the star is still accumulating mass. Every new observation reveals more connections, more interactions, more ways that stars and their surroundings influence each other. Future missions will probe the interstellar medium in even greater detail. The proposed interstellar probe would travel beyond the influence of our Sun, directly sampling the interstellar medium and sending back measurements for decades. Such a mission would tell us about the density, composition, temperature, and magnetic field of the local interstellar medium, giving us ground truth to compare with our remote observations. It would be humanity's first direct exploration of the sea between the stars, our first physical bridge to interstellar space. As you drift deeper into contemplation of these cosmic connections, feeling perhaps the weight of your eyelids growing heavier, consider that you are immersed in this same interstellar medium. Yes, Earth's atmosphere shields us from direct contact, but cosmic rays penetrate the atmosphere, neutrinos pass through the entire planet, and the gravitational and magnetic influences of the galaxy shape our solar system's motion through space. We are not separate from the interstellar medium, but swimming through it, part of it, connected through it to every star we see, and every star we don't see. Now we expand our view even further, lifting ourselves above our galaxy entirely, rising into the vast spaces between galaxies, where an even grander network reveals itself, a cosmic web so vast, so beautiful, so intricate that it challenges our ability to comprehend while simultaneously confirming our deepest intuition that everything in the universe is connected. Here, in the larger structures we can observe, we find perhaps the most compelling evidence for bridges, not just between stars but between entire galaxies, between clusters of galaxies, between all the matter and energy in the observable universe. Let's float together in this ultimate vastness, where billions of galaxies are arranged not randomly, but in patterns that speak of deep, fundamental connections operating across billions of light years. The discovery of the cosmic web is one of the most profound revelations in modern cosmology. For most of human history, we didn't even know other galaxies existed. It wasn't until the 1920s that Edwin Hubble proved that the spiral nebulae visible in telescopes were actually other galaxies, island universes like our own Milky Way, but millions of light years away. This discovery expanded our conception of the universe by factors of millions, but it was only the beginning. As telescopes improved and surveys grew larger, we began to see that galaxies aren't scattered randomly through space, but are organized into structures that boggle the mind with their scale and complexity. Imagine, if you can, a three-dimensional spider web the size of the observable universe. The strands of this web are made not of silk but of galaxies, millions and billions of them, arranged along filaments that can stretch for hundreds of millions of light years. Where filaments meet, there are nodes, massive clusters containing thousands of galaxies. Between the filaments are voids, vast regions with very few galaxies, like bubbles in cosmic foam. This is the cosmic web, the largest structure we know of, the architecture of the universe itself on the grandest scale we can observe. The cosmic web isn't just a pattern we see, it's a prediction of our best theories of how the universe evolved. According to the standard model of cosmology, the universe began in a hot, dense state 13.8 billion years ago. At that time, matter was distributed almost uniformly, with tiny variations in density that were quantum fluctuations stretched to cosmic scales by inflation. Over billions of years, gravity amplified these tiny variations. Regions that were slightly denser attracted more matter, becoming denser still. Regions that were slightly less dense lost matter to their denser neighbours, becoming even emptier. This process, operating over cosmic time, created the web-like structure we see today. But here's where it gets even more interesting. The cosmic web is made mostly of dark matter, that mysterious substance we can't see directly but know must exist. Ordinary matter, the stuff that makes up stars and planets and us, comprises only about 5% of the universe. Dark matter makes up about 27%, and dark energy, which is causing the expansion of the universe to accelerate, makes up the remaining 68%. The cosmic web we can see, traced by the light of galaxies, is just the tip of the iceberg. There's a much larger dark matter web that we can only detect through its gravitational effects and the visible galaxies formed, where dark matter was densest, like dew condensing on a spider web. The Sloan Digital Sky Survey, one of the most ambitious astronomical projects ever undertaken, has mapped millions of galaxies, revealing the cosmic web in unprecedented detail. Using a telescope in New Mexico, astronomers have measured the positions and distances of galaxies across a large fraction of the sky, creating three-dimensional maps that show the filamentary structure of the universe. These maps are like CT scans of the cosmos, revealing the internal structure of space itself, and what they show is breathtaking. Walls of galaxies millions of light-years across, filaments stretching between clusters like cosmic highways, voids so large that light would take hundreds of millions of years to cross them. One of the most striking features revealed by these surveys is the Great Wall, or more properly the CFA2 Great Wall, a sheet of galaxies over 500 million light-years long, 300 million light-years wide, but only 15 million light-years thick. Discovered in 1989, it was the largest structure known in the universe for many years. But as surveys have grown larger and deeper, even larger structures have been found. The Sloan Great Wall, discovered in 2003, is nearly 1.4 billion light-years long. The Hercules Corona Borealis Great Wall, identified in 2013, may be over 10 billion light-years across, though its exact nature is still debated. These structures are so large that they challenge our understanding of how structure formation works in the universe. But the cosmic web isn't static. It's evolving, growing, changing. Galaxies move along the filaments like cars on cosmic highways, flowing toward the nodes where galaxy clusters grow ever more massive. Computer simulations of the universe, using supercomputers to calculate the gravitational interactions of billions of particles over billions of years, show the cosmic web forming and evolving. These simulations, with names like the Millennium Simulation and the Illustris Project, create virtual universes that look remarkably like the real one, suggesting that we understand at least the basic physics of how the cosmic web forms. The filaments of the cosmic web are more than just alignments of galaxies. They're thought to contain streams of gas, rivers of ordinary matter flowing along the dark matter scaffolding. This gas is extremely hot, millions of degrees, heated by the gravitational energy released as it falls into the web. It's also extremely diffuse, far more rarefied than the interstellar medium we discussed earlier, but there's so much of it that it contains more ordinary matter than all the galaxies combined. This is the missing baryon problem. When we add up all the ordinary matter we can see in stars and galaxies, we only account for about half of what should exist based on measurements of the early universe. The rest is thought to be in these filaments, in gas so hot and diffuse that it's nearly impossible to detect. X-ray telescopes have begun to detect this hot gas in the filaments. The XMM Newton telescope and the Chandra X-ray Observatory have found X-ray emission from gas in some of the denser filaments, confirming that they contain hot gas as predicted. Future X-ray missions with greater sensitivity will be able to map this gas in detail, revealing the ordinary matter component of the cosmic web. This gas represents a physical bridge between galaxies, a medium through which matter and energy can flow on intergalactic scales. The cosmic web also affects how galaxies form and evolve. Galaxies that live in dense regions of the web, in clusters and groups, evolve differently from isolated galaxies in the voids. Cluster galaxies tend to be elliptical, with older stars and little ongoing star formation. They've been stripped of their gas by interactions with other galaxies, and with the hot gas that fills clusters. Galaxies in less dense regions tend to be spirals like our Milky Way, with ongoing star formation and plenty of gas. The environment shapes the galaxy, and the cosmic web creates that environment. Galaxy clusters, the nodes of the cosmic web, are the largest gravitationally bound structures in the universe. They contain hundreds or thousands of galaxies, vast amounts of hot gas, and enormous amounts of dark matter. The Coma cluster, one of the nearest rich clusters to us, contains over 1,000 galaxies that we can see, and probably many more too faint to detect. The galaxies orbit around the cluster's center of mass at speeds of hundreds of kilometers per second, held in their orbits by the cluster's enormous gravity. The space between galaxies in a cluster is filled with gas heated to tens of millions of degrees, gas that emits X-rays and contains more mass than all the galaxies combined. But even galaxy clusters aren't isolated. They're connected to other clusters by filaments, and they grow by accreting galaxies and smaller clusters that flow along these filaments. The Virgo cluster, the nearest large cluster to us, is currently pulling in galaxies from the surrounding region, including our own local group of galaxies. We're falling toward Virgo at about 200 kilometers per second, though we'll never reach it because the expansion of the universe is carrying us apart faster than gravity is pulling us together. This is one of the strange features of the cosmic web. It's embedded in expanding space. So while gravity creates local structures, the overall web is stretching and dilating. Dark energy, the mysterious force causing the expansion of the universe to accelerate, adds another layer of complexity to the cosmic web. As space expands, the filaments stretch, the voids grow larger, and the average density of the universe decreases. Eventually, billions of years from now, the expansion will overcome gravity except in the most tightly bound systems. Clusters will become isolated islands in an ever-expanding void. The cosmic web will fade and dissolve, its bridges broken by the inexorable expansion of space. But that's billions of years in the future. For now, the web remains intact, a testament to the power of gravity to create structure from near uniformity. The cosmic microwave background, CMB, the afterglow of the Big Bang, provides another window into the cosmic web. This radiation has been travelling through space for 13.8 billion years, and during that journey, it has been subtly affected by the matter it has passed through and around. Massive structures like galaxy clusters leave imprints on the CMB through gravitational lensing and other effects. By studying these imprints, cosmologists can map the distribution of matter, including dark matter, between us and the CMB. This technique, called CMB lensing, reveals the cosmic web in a different way, showing us the total matter distribution rather than just the galaxies. The Planck satellite, which mapped the CMB in exquisite detail from 2009 to 2013, revealed these subtle distortions and used them to map the matter distribution in the universe. The maps show the same web-like structure seen in galaxy surveys, but with better coverage of the dark matter component. They confirm that the cosmic web is real, not just a pattern we're imagining in the galaxy distribution, but a fundamental feature of how matter is organized in the universe. Gravitational waves, ripples in space-time itself, provide yet another probe of the cosmic web. When massive objects accelerate, they create gravitational waves that propagate through space at the speed of light. The LIGO and Virgo detectors have detected gravitational waves from merging black holes and neutron stars, opening a new window on the universe. As these waves travel through space, they're affected by the matter they pass through. Future gravitational wave detectors might be able to use these effects to map the cosmic web in yet another way, revealing aspects invisible to electromagnetic radiation. But perhaps the most intriguing aspect of the cosmic web is what it tells us about the initial conditions of the universe. The tiny density fluctuations in the early universe that seeded the cosmic web are thought to have been quantum fluctuations, microscopic uncertainties stretched to cosmic scales by inflation. This means that the largest structures in the universe, these filaments and voids spanning hundreds of millions of light years, have their origins in quantum mechanics, in the fundamental uncertainty that governs the smallest scales. The cosmic web is a bridge between the quantum and the cosmic, a structure that links the smallest and largest scales we know of. Recent discoveries have revealed even more complexity in the cosmic web. The South Pole Telescope and the Atacama Cosmology Telescope have found evidence for the Sunyaev-Zeldovich effect, where CMB photons are scattered by hot gas in galaxy clusters and filaments. This effect allows us to detect gas that's too diffuse to see directly, revealing more of the ordinary matter in the cosmic web. These observations show that the filaments contain more gas than we thought, that the bridges between galaxies are more substantial than we realized. The Dark Energy Survey, using a telescope in Chile, has mapped hundreds of millions of galaxies to study the cosmic web and its evolution. By comparing the web at different distances, which correspond to different times in the universe's history, astronomers can see how the web has grown and evolved. They find that the web has become more pronounced over time, with denser filaments and emptier voids, as gravity has had more time to amplify the initial density fluctuations. The universe is becoming more structured, more web-like, even as it expands. Computer simulations have become incredibly sophisticated, able to model not just the dark matter component of the cosmic web, but also the ordinary matter, including gas dynamics, star formation, and feedback from supernovae and black holes. The illustrious TNG project, for example, simulates a volume of space over 1 billion light-years across, following the formation and evolution of millions of galaxies. These simulations show that the cosmic web is even more complex than we can observe, with substructure within filaments, streams of gas flowing along the dark matter scaffolding, and magnetic fields threading through the entire network. One of the most fascinating predictions from simulations is that galaxies can affect each other across the cosmic web, even when they're not directly interacting. Gas stripped from one galaxy can flow along a filament and be accreted by another galaxy millions of light years away. Supermassive black holes in galaxy centers can launch jets that heat gas throughout a filament, affecting star formation in galaxies far from the black hole. The cosmic web is not just a passive structure but an active network through which matter, energy, and influence flow. As we contemplate the cosmic web, it's natural to wonder about our place within it. The Milky Way is part of the Local Group, a small collection of galaxies that includes Andromeda and dozens of smaller galaxies. The Local Group is on the outskirts of the Virgo supercluster, which itself is part of an even larger structure called Laniakea, a supercluster containing about 100,000 galaxies spread across 500 million light-years. We're not in a particularly special location in the cosmic web, neither at a major node nor in the depths of a void, but somewhere in between, on a modest filament in an unremarkable region of the universe. Yet this unremarkable location has allowed us to exist and to contemplate the cosmic web itself. If we were in a dense cluster, the night sky would be filled with galaxies, and the intense radiation and gravitational interactions might have prevented the stable conditions necessary for life. If we were in a void, we might not have had enough nearby matter to form the stars and planets necessary for our existence. Our position in the cosmic web, ordinary as it might be, is perfect for the emergence of observers capable of discovering and wondering about the web itself. The cosmic web also raises profound questions about the nature of the universe. Why does the universe have this particular structure? Why are the filaments and voids the sizes they are? These questions lead us back to the fundamental constants of nature, the strengths of the fundamental forces, the amount of dark matter and dark energy. Small changes in any of these would lead to a very different cosmic web or no web at all. The fact that the universe has parameters that allow for such rich structure, and ultimately for our existence, is one of the deepest mysteries in cosmology. Future telescopes will reveal the cosmic web in even greater detail. The James Webb Space Telescope is already showing us galaxies in the early universe, revealing how the first structures formed and began to trace out the cosmic web. The Nancy Grace Roman Space Telescope, scheduled for launch in the mid-2020s, will survey large areas of the sky to map the cosmic web and study its evolution. The Euclid mission from the European Space Agency will map billions of galaxies to understand the geometry of the cosmic web and the nature of dark energy. The Vera Rubin Observatory in Chile will survey the entire visible sky every few nights, revealing how the cosmic web changes over time. Even more ambitious projects are being planned. The Square Kilometre Array, a radio telescope being built in Australia and South Africa, will be able to detect the 21-centimetre emission from hydrogen in the early universe, mapping the cosmic web before the first galaxies formed. This will show us the primordial web, the initial structure from which everything else evolved. Space-based gravitational wave detectors like LISA will detect the mergers of supermassive black holes throughout the universe, using them as beacons to map the cosmic web through gravitational lensing. As you lie there, perhaps feeling sleep beginning to embrace you like the cosmic web embraces galaxies, consider that you are part of this vast structure. The atoms in your body have travelled along the filaments of the cosmic web, been part of galaxies that merged and interacted, been recycled through generations of stars. You're not observing the cosmic web from outside, you're woven into it, a conscious part of the universe's largest structure. The bridges between galaxies are not abstract concepts, but the actual paths along which the matter that makes you has travelled across billions of years. The cosmic web tells us that the universe is not a collection of isolated objects scattered through empty space, but a single interconnected system. Every galaxy affects every other galaxy through gravity, through the gas that flows between them, through the light they exchange, through the cosmic expansion they all participate in. The bridges are real, physical, observable. They operate on scales so vast that light takes millions of years to cross them, yet they bind the universe into a coherent whole. In the profound quiet of space, where no human ear could ever detect a sound, the universe is actually singing, broadcasting, whispering across the vast distances in ways we're only beginning to learn how to hear. Every star, every galaxy, Every cosmic phenomenon emits signals across the electromagnetic spectrum and beyond, creating an invisible network of communication that might represent the most subtle and pervasive bridges of all. Tonight, let's become cosmic listeners together, tuning our imaginations to these signals in the silence, these messages that travel between stars carrying information we're still learning to decode. Let's explore how we listen to the universe and what these cosmic signals might tell us about the hidden connections between all things. The idea of listening to space might seem paradoxical at first. After all, sound as we know it requires a medium to travel through, air or water or solid matter, and space is essentially a vacuum. But the universe speaks in other languages: radio waves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays, gravitational waves, neutrinos, cosmic rays. Each of these carriers of information travels through space, largely unimpeded, carrying messages from their sources to anyone with the ability to detect them. We've spent the last century developing that ability, building ever more sensitive instruments to hear what the universe is saying. Radio astronomy was our first way of listening to the invisible universe. In 1932, Carl Jansky, an engineer working for Bell Telephone Laboratories, was investigating sources of static that might interfere with transatlantic radio communications. He built a large antenna and discovered a persistent hiss that seemed to come from the constellation Sagittarius. He had detected radio waves from the center of our galaxy, opening an entirely new window on the cosmos. The universe, it turned out, was broadcasting on radio frequencies, and we had just learned how to tune in. Since Jansky's discovery, radio telescopes have revealed a universe far more active and dynamic than anyone imagined. Pulsars, rapidly rotating neutron stars, broadcast regular pulses of radio waves like cosmic lighthouses. Some pulsars are so regular that they rival atomic clocks in their precision. The first pulsar discovered, by Jocelyn Bell Burnell in 1967, pulsed so regularly that she and her advisor initially wondered if they had detected signals from an alien civilization. They called it LGM-1, for Little Green Men, before realizing they had discovered a new type of astronomical object. Pulsars are perhaps the universe's most obvious beacons, natural broadcasts that propagate across thousands of light years. Each pulsar has its own signature, its own rhythm, determined by its rotation rate and magnetic field strength. Some pulse dozens of times per second, others only once every few seconds. Some are slowing down as they lose energy, others are speeding up as they accrete matter from companion stars. By monitoring these pulses, astronomers can detect planets orbiting pulsars, measure the properties of the interstellar medium, test theories of gravity, and even detect gravitational waves through their effect on pulsar timing. But pulsars are just one voice in the cosmic chorus. Radio galaxies, powered by supermassive black holes at their centers, broadcast across millions of light years. These active galactic nuclei launch jets of particles at nearly the speed of light, and these particles emit radio waves as they spiral through magnetic fields. Some radio galaxies are so powerful that they outshine their entire host galaxy in radio light, broadcasting their presence across billions of light years. These are cosmic megaphones, announcing the presence of black holes to the entire observable universe. The SETI Institute, the search for extraterrestrial intelligence, represents humanity's deliberate attempt to listen for artificial signals from other civilizations. Using radio telescopes around the world, SETI researchers scan the sky for signals that might indicate the presence of intelligent life elsewhere in the universe. They look for narrow-band signals, transmissions at very specific frequencies that nature doesn't typically produce. They search for patterns, regularities, mathematical relationships that might indicate an artificial origin. So far, no confirmed detection has been made, but the search continues, and the very act of listening represents a profound hope that we're not alone, that there might be other nodes of consciousness in the cosmic network. The Allen Telescope Array in California, dedicated to SETI research, can observe multiple star systems simultaneously, listening for any artificial signals. The Breakthrough Listen project, funded by billionaire Yuri Milner, is conducting the most comprehensive search for intelligent life ever undertaken, observing millions of stars and hundreds of galaxies for signs of technology. These projects represent humanity's attempt to detect bridges of communication that might already exist, signals crossing between stars carrying messages from other civilizations. But even without detecting artificial signals, our radio observations reveal natural communication networks in space. Molecules in interstellar clouds emit radio waves at specific frequencies, creating spectral lines that identify their presence and properties. These molecular emissions are like chemical signatures broadcast across space. When we detect formaldehyde or methanol, or more complex organic molecules in distant clouds, we're reading messages about the chemistry happening in those regions, chemistry that might be similar to what happened in our own solar system before life began. Fast radio bursts, FRBs, are one of the newest mysteries in radio astronomy. First discovered in 2007, these are intense pulses of radio waves that last only milliseconds, but release as much energy as the sun emits in days. They come from distant galaxies, billions of light years away, and their cause is still debated. Some might be from magnetars, neutron stars with incredibly strong magnetic fields. Others might have different origins we haven't imagined yet. What's certain is that something in distant galaxies is broadcasting powerful signals that we're only now learning to detect and interpret. The CHIME telescope in Canada has detected hundreds of fast radio bursts, including some that repeat. These repeating FRBs are particularly intriguing because they allow detailed study. One repeating source, FRB 12112, has been traced to a dwarf galaxy 3 billion light-years away. The signals from this source are rotated by magnetic fields, telling us about the magnetic environment around the source. Each burst carries information about its journey through space, modified by all the matter and fields it encountered along the way. Moving beyond radio waves, we find other forms of cosmic communication. Gravitational waves, first directly detected in 2015, represent an entirely different way the universe transmits information. When massive objects accelerate, they create ripples in space-time itself that propagate outward at the speed of light. The LIGO and Virgo detectors have now detected dozens of gravitational wave events, mostly from merging black holes, but also from merging neutron stars. Each detection tells us about events happening hundreds of millions or billions of light-years away, events so violent they shake the fabric of space itself. The merger of two neutron stars detected in 2017, called GW127, was particularly remarkable because it was also observed in electromagnetic radiation. Telescopes around the world and in space detected the gamma-ray burst, optical light, infrared, ultraviolet, X-rays, and radio waves from the merger. This multi-messenger observation showed us that cosmic events can broadcast across multiple channels simultaneously, each carrying different information about the event. The gravitational waves told us about the masses and spins of the neutron stars. The gamma rays revealed the formation of a jet. The optical and infrared light showed us heavy elements being created in the merger. It was like hearing a cosmic symphony with all the instruments playing together. Neutrino astronomy represents another way of listening to the universe. Neutrinos are subatomic particles that barely interact with matter, allowing them to travel through the universe almost unimpeded. They are produced in the cores of stars, in supernovae, in cosmic ray interactions, possibly in dark matter annihilation. Because they interact so weakly, they're incredibly difficult to detect, requiring massive detectors often buried deep underground or in ice to shield them from other particles. The IceCube Neutrino Observatory at the South Pole uses a cubic kilometre of Antarctic ice as a detector. When a high-energy neutrino occasionally interacts with an atom in the ice, it produces a cascade of particles that emit light, which is detected by thousands of sensors embedded in the ice. IceCube has detected neutrinos from outside our solar system, including some that have been traced back to specific sources like blazars, active galactic nuclei with jets pointed toward Earth. These neutrinos carry information about the most extreme environments in the universe, places where particles are accelerated to energies we can't achieve on Earth. The Super Kamiokande detector in Japan, a tank containing 50,000 tons of pure water surrounded by light detectors, has been observing neutrinos for decades. In 1987, it detected neutrinos from a supernova in the Large Magellanic Cloud, 168,000 light-years away. The detection of just 24 neutrinos told us about the core collapse that triggered the supernova, confirming our theories about how massive stars die. Those 24 particles were messengers from a stellar catastrophe. carrying information that light couldn't provide because it took hours to escape from the dense collapsing star while the neutrinos escaped almost immediately. Cosmic rays, high-energy particles that constantly bombard Earth, represent yet another form of cosmic signal. These particles, mostly protons but also heavier nuclei and electrons, carry enormous amounts of energy. Some have energies millions of times greater than we can achieve in our most powerful particle accelerators. They are accelerated by supernovae, by black holes, by processes we don't fully understand, and they travel through space for millions of years before reaching us. The Pierre Auger Observatory in Argentina uses an array of detectors spread over 3,000 square kilometers to detect the highest energy cosmic rays. When these particles strike Earth's atmosphere, they create cascades of secondary particles that rain down over large areas. By detecting these showers, astronomers can determine the energy and arrival direction of the original cosmic ray. The highest energy cosmic rays are so energetic that they must come from relatively nearby sources within a few 100 million light-years, because interactions with the cosmic microwave background would slow them down over greater distances. These particles are messengers from the most extreme particle accelerators in the universe. But cosmic rays don't travel in straight lines. The magnetic fields in our galaxy and in intergalactic space deflect them, scrambling their arrival directions. This makes it difficult to determine exactly where they come from. However, this deflection itself tells us about the magnetic fields in space. Cosmic rays are like test particles that probe the invisible magnetic architecture of the universe. Their deflected paths trace out the field lines, revealing structures we couldn't see any other way. The Fermi Gamma Ray Space Telescope has been mapping the gamma ray sky since 2008, detecting the highest energy form of electromagnetic radiation. Gamma rays are produced in the most violent events in the universe: matter falling into black holes, particles accelerated in pulsar magnetospheres, cosmic rays colliding with interstellar gas. Fermi has detected thousands of gamma ray sources, including mysterious bubbles of gamma ray emission extending above and below our galaxy's center, possibly inflated by past activity of the Milky Way's central black hole. One of the most intriguing discoveries in gamma ray astronomy is the detection of gamma rays from thunderstorms on Earth. Lightning and thunderclouds can accelerate electrons to high energies, producing terrestrial gamma ray flashes. This shows that the same physical processes operating in distant cosmic sources also occur in our own atmosphere. We're connected to the cosmos not just through the matter we're made of, but through the physical processes that operate both here and in the farthest reaches of space. The study of transient events, things that appear and disappear in the sky, has revealed that the universe is far more dynamic than we once thought. The Zwicky Transient Facility in California scans the entire visible sky every few nights, detecting supernova, asteroids, variable stars, and other changing objects. The Vera Rubin Observatory, beginning operations soon, will survey the sky even more frequently and deeply. These surveys are showing us that the universe is constantly changing, with stars exploding, black holes flaring, and new phenomena appearing all the time. Some transients remain mysterious. In 2007, astronomer Stephen Smart and his team discovered a type of supernova that was much fainter and faster fading than normal supernovae. These calcium-rich transients might be white dwarf stars exploding in unusual ways, but we're not sure. Every year brings discoveries of new types of transients, new ways the universe signals changes and events. Each type of transient is a different voice in the cosmic conversation, a different type of bridge carrying information across space. The Transiting Exoplanet Survey Satellite, TESS, is monitoring hundreds of thousands of stars for the tiny dimming that occurs when a planet passes in front of its star. But TESS is also detecting stellar flares, binary star eclipses, and other forms of stellar variability. Every star, it seems, has its own rhythm of variation, its own pattern of signals. Some vary regularly, others chaotically. Some have sudden outbursts, others gradual changes. These variations propagate across space as changes in light and stellar wind, potentially affecting any planets orbiting these stars and serving as signals to the rest of the universe about the star's behavior. Even our Sun, which seems constant to us, varies on multiple timescales. The 11-year solar cycle sees the Sun's magnetic field reverse and its activity wax and wane. Solar flares and coronal mass ejections send bursts of particles and radiation into space. These variations affect Earth's climate, atmosphere, and technology. They also propagate outward, becoming part of the Sun's signal to the rest of the galaxy. Any observer in another star system studying our Sun would see these variations, these messages broadcast in light and particles. The Parker Solar Probe, diving closer to the Sun than any previous spacecraft, is revealing the complexity of the solar wind and the Sun's extended atmosphere. It has discovered magnetic switchbacks, sudden reversals in the magnetic field that we don't fully understand. It's shown that the solar wind is far more turbulent and variable than we expected. These discoveries suggest that every star's wind is a complex dynamic signal, carrying information about the star's magnetic field, rotation, and internal dynamics. Looking to the future, new ways of listening to the universe are being developed. The Square Kilometre Array will be the world's largest radio telescope, able to detect incredibly faint signals from the early universe. The Laser Interferometer Space Antenna, LISA, will detect gravitational waves from space, sensitive to lower frequencies than ground-based detectors. The Cherenkov Telescope Array will detect very high-energy gamma rays with unprecedented sensitivity. Each new instrument is like developing a new sense, a new way of perceiving the cosmic signals that surround us. But perhaps the most profound aspect of listening to the universe is not the signals we detect, but what they represent. A cosmos in constant communication with itself. Every particle, every wave, every field is carrying information from one part of the universe to another. The signals cross and interfere, creating patterns of constructive and destructive interference. They're modified by their journeys, picking up information about everything they encounter. The universe is not silent but full of signals, a constant exchange of information that connects everything to everything else. As you drift towards sleep, perhaps you can imagine yourself as a receiver, tuned to the cosmic signals that constantly pass through you. Neutrinos from the Sun, from distant supernova, from the Big Bang itself stream through your body. Cosmic rays strike the atoms in your cells, occasionally causing mutations that drive evolution. Radio waves from pulsars, from galaxies, from the cosmic web, pass through you undetected. Gravitational waves from distant black hole mergers compress and stretch the space you occupy, by amounts too small to perceive but real nonetheless. You are immersed in a sea of signals, a node in the cosmic communication network. The search for patterns in these signals, for correlations and connections, is ongoing. Perhaps pulsars in different parts of the galaxy pulse in subtle synchrony. Perhaps fast radio bursts trigger responses in other cosmic sources. Perhaps the universe has communication channels we haven't discovered yet, signals that travel faster than light through quantum entanglement or extra dimensions. The silence of space is an illusion created by our limited senses. In reality, space is full of signals, full of information, full of connections waiting to be discovered. The bridges between stars might not be structures we can see, but signals we can detect, carriers of information that link every part of the universe to every other part. These signals create a kind of cosmic nervous system, allowing different regions of space to influence and respond to each other. We're only beginning to develop the technology and understanding to perceive this network, to decode its messages, to understand its implications. But already we can see that the universe is far more connected, far more communicative than we ever imagined. As this middle section of our journey draws to a close, we've explored the physical evidence for connections between stars and galaxies, from the threads of gravity and magnetism in the interstellar medium to the vast filaments of the cosmic web, from the constant stream of signals crossing space to the mysteries we're still trying to understand. The universe reveals itself as not a collection of isolated objects, but a unified system, with bridges operating at every scale, connections that link the smallest particles to the largest structures, the nearest stars to the most distant galaxies, the present moment to the deep past and far future. And we've only begun to explore what these connections might mean. Now we turn inward, gently, like a telescope reversing its gaze to become a microscope, and we discover something remarkable. The bridges between stars that we've been contemplating might also exist within us, not just in the atoms that compose our bodies, but in the very nature of consciousness, memory, and meaning itself. Here, in the soft space between sleeping and waking where you might be floating right now, we explore how the cosmic connections we've been imagining might be reflected in the networks of our own minds, how the universe's tendency to build bridges might be the same tendency that allows you to think, to dream, to wonder about your place among the stars. Let's explore together how the macrocosm of the universe might be mirrored in the microcosm of human consciousness, and how this reflection might itself be one of the most profound bridges of all. Think about what's happening in your brain right now as you listen to these words. Billions of neurons are firing in intricate patterns, creating electrical and chemical signals that somehow give rise to your experience of understanding, of imagination, of perhaps feeling drowsy and peaceful. Each neuron connects to thousands of others through synapses, creating a network so complex that we're only beginning to map it. The Human Connectome Project, attempting to chart all the connections in the human brain, has revealed that our brains contain about 86 billion neurons with roughly 100 trillion connections between them. This is a number that rivals the number of stars in 1,000 galaxies, all contained within the soft tissue inside your skull. The structure of neural networks bears an uncanny resemblance to the cosmic web we explored earlier. Neurons cluster in groups and regions, connected by long axons that bundle together like cosmic filaments. There are dense nodes where many connections converge, similar to galaxy clusters. There are quieter regions with fewer connections like cosmic voids. Information flows through the brain in waves and pulses, just as matter and energy flow through the cosmic web. The similarity is so striking that some researchers have used the same mathematical tools to analyze both brain networks and the cosmic web, finding similar patterns of organization at vastly different scales. But the bridges in our minds aren't just physical connections between neurons. They're also the associations between memories, the links between concepts, the pathways between emotions. When you think of stars, perhaps you remember a night from your childhood when someone first showed you the constellations. That memory connects to the feeling of wonder you experienced, which connects to other moments of awe in your life, which connects to questions about meaning and purpose. Each thought is a bridge to other thoughts, creating a web of meaning that's uniquely yours, yet follows universal patterns of association and connection. Memory itself is a kind of bridge through time. When you remember something, you're creating a connection between the present moment and a past experience. The neurons that fired when you first experienced something fire again in similar patterns when you remember it. But memory isn't a perfect recording. It's reconstructed each time you recall it, influenced by your current state, by other memories, by the very act of remembering. In this way, memory is like the light from stars carrying information from the past but modified by its journey to the present. Dreams are perhaps the most mysterious bridges in our minds. During sleep, especially during REM sleep, your brain creates connections between disparate memories and concepts, weaving them into the strange narratives we call dreams. Dreams might be the brain's way of building new bridges, finding unexpected connections, solving problems by linking things that seemed unrelated during waking hours. The surreal quality of dreams, where impossible things seem perfectly natural, might reflect the brain exploring potential connections without the constraints of waking logic. The default mode network, a set of brain regions that becomes active when we're not focused on the outside world, might be our internal bridge-building system. When you daydream, when your mind wanders, when you're falling asleep, this network activates, creating connections between different parts of your experience. It's been linked to creativity, to self-reflection, to the construction of personal meaning. It's most active during the kind of relaxed, contemplative state you might be in right now, as you drift along with these words about cosmic connections. Language itself is a bridge, isn't it? These words I'm speaking create connections between my thoughts and yours, across the distance between us, across the time between when these words were written and when you're hearing them. Language allows us to share not just information but experience, emotion, wonder. When I describe the vast filaments of the cosmic web, you can imagine them, and in that moment, the pattern exists in your mind as it exists in space. Language builds bridges between minds, allowing us to create shared understanding, shared meaning, shared wonder. Consider how human consciousness might be connected to the cosmos in ways we don't fully understand. We are, after all, the universe becoming aware of itself. The atoms in our brains were forged in stars, assembled on Earth, organized into neurons, and somehow, through processes we don't fully comprehend, these arrangements of matter became capable of contemplating their own origins. When you think about a star, atoms that were once inside a star are thinking about stars. It's a kind of cosmic recursion, the universe reflecting on itself through us. Some physicists and philosophers have suggested that consciousness might be a fundamental property of the universe, like mass or charge. This idea, called panpsychism, proposes that everything has some form of experience or awareness, though nothing like human consciousness except in complex systems like brains. If this were true, it might mean that stars, galaxies, and the cosmic web itself have some form of experience we can't imagine. This is highly speculative and controversial, but it represents an attempt to understand how consciousness fits into the physical universe, how the subjective experience of being aware relates to the objective reality of atoms and forces. Even without embracing such speculative ideas, we can see that consciousness creates real connections in the physical world. When you learn something new, synapses in your brain physically change. When you form a memory, proteins are synthesized and neural pathways are strengthened. When you imagine something, blood flow increases to specific brain regions. Thought has physical consequences, creating and modifying the biological bridges in your brain. And through action, thought affects the wider world, creating bridges between the internal and external, between imagination and reality. The phenomenon of synchronicity, meaningful coincidences that seem too unlikely to be mere chance, might represent another kind of bridge. When you think of someone and they call, when you need something and it appears, when events align in ways that seem meaningful, you might be experiencing connections that operate outside normal causality. Carl Jung, who developed the concept of synchronicity, suggested it might represent an acausal connecting principle in the universe. While science hasn't validated this idea, the experience of synchronicity is real for many people, creating a sense of connection and meaning that transcends ordinary explanation. Music offers another window into how consciousness creates bridges. When you listen to music, multiple brain regions activate in coordination. Rhythm engages motor areas, melody activates auditory processing regions, and emotional responses involve the limbic system. But music does more than activate individual regions. It synchronizes them, creating coherent patterns of activity across the brain. Groups of people listening to the same music show synchronized brain activity. Their neural patterns aligning in remarkable ways. Music creates bridges within brains and between brains, connecting people through shared rhythms and harmonies. The experience of awe, which you might have felt while contemplating the cosmos, has profound effects on consciousness. Studies have shown that experiencing awe, whether from viewing vast landscapes, contemplating the universe, or witnessing acts of moral beauty, changes how we think and feel. It makes us feel smaller but more connected, less focused on ourselves and more aware of our place in something larger. Awe seems to dissolve the boundaries between self and world, creating a bridge between individual consciousness and the cosmos. Meditation and contemplative practices from various traditions aim to strengthen these bridges between individual consciousness and universal awareness, whether through focused attention, open monitoring, or practices like loving-kindness meditation. These techniques seem to enhance our sense of connection. Brain imaging shows that long-term meditators have increased connectivity between brain regions, stronger bridges within their neural networks. They also report experiences of unity, of feeling connected to all things, of boundaries dissolving between self and cosmos. The placebo effect demonstrates how belief and meaning can create physical changes. When someone believes they're receiving treatment, their brain can trigger real physiological responses, pain reduction, immune system activation, even changes in brain chemistry. This isn't just mind over matter, but mind and matter working together, consciousness affecting biology through pathways we're still discovering. The placebo effect might be seen as consciousness building bridges to healing, using meaning and expectation to influence physical processes. Collective consciousness, the idea that groups of people can share thoughts or awareness, might represent bridges between individual minds. When crowds move in synchrony, when audiences breathe together during a performance, when teams operate in perfect coordination, there seems to be a shared awareness that transcends individual consciousness. Studies of group meditation have found correlations in brain activity and even in random number generators, suggesting that focused group attention might have measurable effects on the physical world. The internet and modern communication technology have created new kinds of bridges between minds. We can share thoughts instantly across the globe, access the accumulated knowledge of humanity, participate in collective problem-solving and creativity. Social media, despite its problems, connects billions of minds in an unprecedented network of communication. We're creating a kind of technological nervous system for humanity, a network that might be the beginning of a truly global consciousness. But let's return to the personal, to your individual experience as you listen to these words. Your consciousness is unique, shaped by your particular history, your specific neural patterns, your individual perspective. Yet it's also universal, following patterns common to all human consciousness, connected to the same cosmos that all humans observe. You are both utterly unique and completely integrated into the fabric of existence. The bridges in your mind connect you to your own past and future, to other people, to the Earth, to the stars. The act of wondering about cosmic connections, which we're engaged in together right now, might itself strengthen those connections. When you contemplate the universe, when you imagine bridges between stars, when you feel awe at the vastness of space and time, you're creating patterns of neural activity that didn't exist before. You're building new bridges in your own consciousness, new connections between concepts and experiences. The universe is changing your brain, and your brain is part of the universe, so the universe is changing itself through your contemplation of it. Stories and myths have always been humanity's way of building bridges of meaning. Every culture has stories about the stars, explanations for how the cosmos came to be, narratives that connect human life to cosmic forces. These stories aren't scientific explanations, but they serve a different purpose. They create meaning, they provide context, they build bridges between the human scale and the cosmic scale. Even our modern scientific understanding of the universe is a kind of story, a narrative we've constructed from observations and mathematics, a bridge between the raw data of reality and human understanding. The search for extraterrestrial intelligence beyond its scientific goals represents a deep human need to find consciousness elsewhere in the universe, to know that the bridges of awareness extend beyond Earth. If we discovered intelligent life elsewhere, it would be the ultimate confirmation that consciousness is not a unique accident, but a natural consequence of cosmic evolution. It would mean that the universe has become aware of itself not just through us, but through countless other perspectives, other nodes of consciousness connected by the vast bridges of space and time. Your personal search for meaning, for purpose, for understanding your place in the universe is part of this cosmic awakening. Every time you wonder about the stars, every time you feel connected to something larger than yourself, every time you experience love or beauty or truth, you're participating in the universe's self-discovery. Your consciousness is not separate from the cosmos, but an integral part of it. A way the universe experiences itself, knows itself, wonders about itself. The bridges of meaning we create through art, science, philosophy, and spirituality are not just human constructs, but expressions of the universe's tendency to create connections. The same force that draws matter together into stars and galaxies might draw thoughts together into understanding, experiences together into meaning, people together into love. The bridges between stars that we've been imagining might be part of a larger pattern of connection that operates at every scale, from the quantum to the cosmic, from the physical to the conscious. As you continue to drift towards sleep, feeling perhaps the gentle dissolution of boundaries that comes with approaching dreams, consider that the bridges in your consciousness are real, physical, meaningful. The connections between your neurons are as real as the connections between stars. The bridges between your memories are as valid as the bridges between galaxies. The meaning you create through contemplation is as significant as any cosmic structure. You're not just observing the universe's tendency to build bridges, you're an expression of that tendency, a living bridge between matter and meaning, between the cosmic and the personal, between what is and what might be. Let us now drift forward in time, not with urgency or anxiety about what's to come, but with the gentle curiosity of dreamers imagining possibilities as we contemplate how humanity might one day travel along these invisible bridges between stars, how future civilizations might use the cosmic connections we've been exploring, and how the universe itself might evolve its networks over the eons ahead. This isn't about predicting the future with certainty, but about wondering, in the soft way one wonders while falling asleep, about the pathways that might open before us and before whatever forms of consciousness might follow us in the cosmic story. Imagine, perhaps 100 years from now, perhaps 1,000, when our understanding of the universe has deepened beyond what we can currently conceive. Just as our ancestors couldn't have imagined detecting gravitational waves or mapping the cosmic web, we likely can't imagine the discoveries that await our descendants. But we can dream about possibilities, and sometimes dreams become blueprints for reality. The bridges between stars that seem invisible and theoretical to us might become as real and navigable to future humans as ocean currents are to sailors or jet streams are to pilots. Consider how we might use gravity as a bridge for interstellar travel. We already use gravitational assist to accelerate spacecraft, having them fly close to planets to gain speed. Voyager 1 and 2 used Jupiter's gravity to reach the outer solar system and eventually interstellar space. But imagine if we could map the gravitational currents between stars with such precision that spacecraft could surf along them, using the subtle variations in space-time as a kind of cosmic highway. These paths might not be straight lines, but graceful curves through space, following the contours of gravitational fields like a leaf following the current of a stream. The Breakthrough Starshot project envisioned sending tiny spacecraft to nearby stars using powerful laser beams to push light sails. These miniature probes, each no bigger than a postage stamp, would accelerate to perhaps 20% of the speed of light, reaching Proxima Centauri in about 20 years. But what if, instead of brute force acceleration, these probes could find and follow natural pathways through space, regions where the interstellar medium is thinner, where magnetic fields create channels, where the resistance to motion is minimized? They might travel like seeds on the wind, following currents we're only beginning to detect. Future telescopes might reveal these pathways in detail. Imagine instruments that can map not just the position and motion of stars, but the entire electromagnetic and gravitational environment between them. We might discover that certain routes through space are naturally favorable for travel, like mountain passes or river valleys on Earth. These routes might wind between stars, taking longer paths in distance, but shorter paths in time or energy. The universe might already have roads. We just need to learn to see them. The interstellar medium itself might become a resource for travelers rather than an obstacle. Those thin wisps of gas and dust between stars contain hydrogen that could fuel fusion reactors, raw materials that could be collected and used. A sufficiently advanced spacecraft might not need to carry all its fuel, but could gather it along the way, like a whale filtering plankton from the ocean. The magnetic fields in space might be used for propulsion or steering, with spacecraft generating their own magnetic fields to push against the galactic field, sailing on magnetic winds we can barely detect today. But perhaps physical travel isn't the only way to traverse the bridges between stars. Information might travel along pathways we haven't discovered yet. Quantum entanglement, though it can't transmit information faster than light according to our current understanding, might have properties we haven't uncovered. Perhaps there are ways to maintain quantum correlations across interstellar distances, creating instantaneous connections between distant points. Not for sending messages in the conventional sense, but for creating correlations, synchronicities, connections that transcend classical communication. Imagine future civilizations that don't travel between stars in ships, but extend their consciousness along these quantum bridges. They might not move their physical bodies through space, but project their awareness, their information patterns, their essential selves along networks of entangled particles. This isn't teleportation in the science fiction sense, but something subtler. The extension of consciousness through quantum correlations, experiencing distant places without traveling to them in any classical sense. The cosmic web itself might become navigable in ways we can't currently imagine. If dark matter is composed of particles we can interact with, future technology might use dark matter streams as guides, or even as propulsion. These invisible rivers that flow through space, connecting galaxies and clusters, might become the interstate highways of future civilizations. Ships might lock onto dark matter currents and follow them across cosmic distances, carried along by forces we're only beginning to infer from their gravitational effects. Consider the possibility of manipulating space-time itself. General relativity allows for exotic solutions like wormholes and Alcubierre drives, shortcuts through space or bubbles of warped space-time that could travel faster than light without violating relativity. These require forms of matter and energy we've never observed, exotic matter with negative energy density. But perhaps such matter exists in the bridges between stars, in the quantum fluctuations of the vacuum, in dimensions we haven't accessed yet. Future civilizations might learn to engineer space-time, creating their own bridges rather than just following natural ones. The bridges might also be temporal, pathways through time as well as space. If the block universe model is correct and all moments in time exist simultaneously, there might be ways to navigate not just through space but through space-time, following world lines that connect different events in the cosmic history. This wouldn't be time travel in the paradox-creating sense, but movement along predetermined paths through the four-dimensional structure of space-time, like following a river that winds through a landscape of past and future. Artificial intelligence might be better suited for interstellar travel than biological life. AI could potentially shut down for centuries-long journeys, experiencing no subjective time during travel. Or it might experience time differently, finding centuries of travel no more tedious than we find a long airplane flight. AI explorers might map the bridges between stars in detail, sending back information about pathways and possibilities, preparing the way for whatever follows. They might even establish a network of communication relays, creating an artificial nervous system that spans the galaxy. But let's think even further into the future, millions or billions of years hence. Stars will continue to form for trillions of years, but eventually star formation will cease. The universe will consist of white dwarfs, neutron stars and black holes, slowly cooling in an expanding cosmos. But even in this far future, the bridges might persist or even become more important. Civilizations might huddle around black holes, extracting energy from their rotation. They might use gravitational waves to communicate across vast distances. They might find ways to tunnel between universe bubbles in an eternal inflation scenario, discovering bridges not just between stars but between universes. The ultimate fate of the universe depends on dark energy, that mysterious force causing cosmic acceleration. If dark energy remains constant, the universe will expand forever, with galaxies eventually disappearing beyond each other's cosmic horizons. But perhaps future civilizations will learn to manipulate dark energy, to strengthen the bridges between galaxies even as space expands. They might create bubbles of space where different physical laws apply, regions where the bridges can be maintained despite cosmic expansion. Some physicists speculate about the possibility of creating new universes, baby universes that bud off from our own. If this is possible, it might represent the ultimate bridge, a connection not just between stars or galaxies but between parent and child universes. Civilizations might not just travel along bridges but create new bridges, new universes, new possibilities for consciousness and complexity to emerge. The cosmic web might extend not just through our universe, but through a multiverse of interconnected realities. Consider too the possibility that we're not the first to contemplate these bridges. If intelligent life has emerged elsewhere in the galaxy or universe, they might have already discovered and mapped the invisible connections between stars. There might be ancient networks we haven't detected, pathways established millions or billions of years ago by civilizations that have long since transcended physical form. What we interpret as natural phenomena might include artificial modifications, cosmic engineering on scales we can't recognize. The Fermi paradox asks why, if the universe is so vast and old, we haven't detected signs of other civilizations. Perhaps the answer lies in the bridges themselves. Maybe advanced civilizations don't broadcast their presence in ways we can detect, but communicate along subtle channels, quantum correlations or gravitational waves or something we haven't discovered. They might be all around us, connected by invisible bridges, and we simply haven't developed the ability to perceive them yet. Future human evolution, whether biological or technological, might be shaped by these cosmic bridges. As we spread across the galaxy, different populations might adapt to different stellar environments, different types of bridges. Humans near massive stars might develop different capabilities than those near red dwarfs. Consciousness itself might evolve, becoming more attuned to cosmic connections, more able to perceive and navigate the bridges between stars. We might become something unrecognizable to current humans, as different from us as we are from bacteria, yet still carrying forward the spark of awareness that makes us wonder about our place in the cosmos. The development of new senses, whether biological or technological, might reveal bridges we can't currently perceive. Just as some animals can sense magnetic fields or see ultraviolet light, future humans might directly perceive gravitational waves, dark matter or quantum fields. The invisible bridges might become visible, as obvious to our descendants as roads are to us. They might wonder how we managed to navigate the cosmos without seeing the pathways that seem so clear to them. Virtual reality and simulated universes might create their own kinds of bridges. Future civilizations might not need to physically travel between stars if they can create perfect simulations of other worlds. They might explore the universe through computation rather than transportation, building bridges of information rather than matter. The distinction between real and simulated might become meaningless if consciousness can exist equally in both domains. The merger of human and artificial intelligence might create new forms of consciousness capable of perceiving and navigating bridges we can't imagine. These hybrid minds might think in ways that transcend current human limitations, seeing patterns across vast scales of space and time, understanding connections that require processing power beyond biological brains. They might discover that consciousness itself is a bridge, a fundamental feature of the universe that connects all things that can observe and be observed. Consider the possibility of collective consciousness on a cosmic scale. Just as individual neurons create consciousness through their collective activity, perhaps civilizations scattered across the galaxy could create a kind of galactic consciousness through their interactions. The bridges between stars might become like synapses, carrying information that creates awareness on scales we can't comprehend. The galaxy itself might become conscious, with each star system a neuron in a vast cosmic brain. But even without such exotic possibilities, the simple expansion of life and consciousness across the galaxy would strengthen the bridges between stars. Every world that develops life, every system that hosts consciousness, becomes a new node in the network of awareness. The bridges multiply and strengthen through the mere presence of observers, of beings capable of wondering about connections and seeking to understand them. The universe becomes more connected simply by being observed and contemplated. The terraforming of worlds, the creation of habitable environments where none existed before, might follow the natural bridges between stars. Seed ships might travel along favourable pathways, carrying the ingredients for life to sterile worlds. These seeds might be biological, technological, or something in between. They might not even need to carry full organisms, but just the information needed to bootstrap life and consciousness using local materials. The bridges would carry not matter but patterns, recipes for creating complexity from simplicity. Space habitats, vast artificial worlds built from asteroid materials, might be positioned along the bridges between stars, creating waypoints for travelers and communication nodes for maintaining galactic civilization. These habitats might be mobile, able to slowly migrate along favorable pathways, following resources or avoiding dangers. They might form caravans, connected communities traveling together through space, maintaining cultural and genetic diversity while exploring the galaxy. The discovery of new physics, new forces, new dimensions might reveal bridges we can't currently imagine. Just as the discovery of electromagnetism opened up possibilities for technology that transformed civilization, future discoveries might enable forms of travel and communication that seem like magic to us. Perhaps there are forces that only operate on cosmic scales, too weak to detect in laboratories but capable of creating connections across light years. Perhaps consciousness itself generates a field that future technology could detect and manipulate. As you contemplate these possibilities, feeling perhaps the boundary between waking thought and dream beginning to blur, remember that the future is not fixed but fluid, shaped by choices and discoveries yet to be made. The bridges between stars might remain forever invisible, or they might become as real and solid as the ground beneath our feet. We might remain confined to Earth, or we might spread across the galaxy and beyond. The universe might be empty of other consciousness, or it might be teeming with awareness we haven't learned to recognize. What seems certain is that the human drive to explore, to connect, to understand, will continue to push us toward these bridges, whether they're physical or conceptual, real or imagined. Every generation builds on the discoveries of the previous one, seeing a little farther, understanding a little more. The children being born today might live to see the first confirmed detection of life elsewhere in the universe. Their children might see the launch of the first interstellar colonies. Their children's children might take travelling between stars for granted, following bridges that we can only dream about. The universe has spent 13.8 billion years evolving from simplicity toward complexity, from uniformity toward structure, from unconsciousness toward awareness. This process seems likely to continue, with consciousness spreading across the cosmos, creating new connections, new bridges, new possibilities. We are part of this process, not separate observers, but active participants in the universe's self-organization and self-discovery. The bridges we imagine might become the bridges we create, and the bridges we create might reveal bridges that were always there, waiting for conscious beings to discover and traverse them. And now we come to rest, like a spacecraft finally entering a stable orbit after a long journey, finding ourselves back where we started, but with a transformed perspective on the question that began our contemplation. What if every star was connected by invisible bridges? After our long journey through the scales of the cosmos, from the quantum to the galactic, from the beginning of time to the far future, from the depths of space to the depths of consciousness, we return to this simple, beautiful question, not with a definitive answer, but with something perhaps more valuable, a deeper appreciation for the question itself and what it reveals about the universe and our place within it. The question of invisible bridges between stars is, in many ways, a question about the nature of reality itself. Is the universe a collection of separate objects interacting through forces, or is it a unified whole that only appears separate because of our limited perception? The answer, as we've discovered, might be both and neither. The universe reveals itself differently depending on how we look at it, what questions we ask, what instruments we use to observe it. The bridges might be real at some scales and metaphorical at others, physical in some dimensions and conceptual in others. This isn't a failure to find the truth, but a recognition that truth itself might be richer and more multifaceted than we expected. Science has shown us that the universe is far more connected than it appears to casual observation. Gravity links every particle to every other particle. Electromagnetic radiation carries information across cosmic distances. Quantum entanglement creates correlations that transcend classical space-time. The cosmic web reveals that matter is organized into vast structures that span billions of light years. Dark matter and dark energy, whatever they are, seem to connect and affect everything we can see. The interstellar medium, once thought empty, is full of gas and dust and magnetic fields that create physical pathways between stars. Every discovery reveals new connections, new bridges, new ways that distant things influence each other. But science has also shown us the limits of connection. The speed of light sets a boundary on how quickly information can travel. The expansion of the universe means that distant galaxies are moving away from us faster than light, creating cosmic horizons beyond which we cannot see or communicate. Quantum mechanics, despite its non-local correlations, doesn't allow faster-than-light communication. The second law of thermodynamics ensures that entropy increases, that structures eventually decay, that bridges eventually crumble. The universe is connected but also fragmented, unified but also diverse, bridged but also separated. This paradox of connection and separation might be fundamental to existence itself. Without separation, there would be no structure, no complexity, no possibility for consciousness to emerge. Without connection, there would be no interaction, no evolution, no possibility for separated things to come together in new configurations. The universe needs both bridges and gaps, both connection and isolation, both unity and diversity. The invisible bridges between stars might be most meaningful, not as absolute connections, but as the possibility of connection, the potential for separated things to influence and communicate with each other. Living with this unfinished answer, this permanent mystery, might be more valuable than having a complete explanation. Mystery invites wonder, and wonder is perhaps the most important bridge of all. The bridge between the known and unknown, between current understanding and future discovery, between human consciousness and the cosmos. If we knew everything, if all questions were answered, if all bridges were mapped, would we lose something essential about what makes us human? The unfinished answer keeps us searching, wondering, imagining, and in that searching we create meaning. Consider how differently various cultures have imagined the connections between stars. Aboriginal Australians see songlines in the sky, paths that connect sacred sites on Earth with patterns in the heavens. Ancient Chinese astronomers saw the sky as a mirror of Earth, with celestial events reflecting and influencing terrestrial affairs. The Maya tracked the movements of planets with incredible precision, seeing time itself as cyclical, with events connected across vast spans of years. Modern Western science sees mathematical laws and physical forces connecting all things. Each perspective reveals different aspects of cosmic connection, different bridges that might all be simultaneously true. The question of bridges between stars also reflects our deep human need for connection. We are social beings, evolved to live in communities, to form relationships, to seek connection with others and with something greater than ourselves. When we imagine bridges between stars, we're projecting this need onto the cosmos, seeking confirmation that connection is not just a human peculiarity, but a fundamental feature of the universe. And perhaps we're right. Perhaps the universe tends toward connection just as it tends toward complexity, toward consciousness, toward contemplation of itself. Your personal relationship with the night sky, with the stars you can see and the vast cosmos you can only imagine, is itself a bridge. When you look up at the stars, photons that have traveled for years through space enter your eyes and trigger cascades of neural activity that become thoughts and feelings. You are physically connected to the stars through these photons, through gravity, through your shared origin in the Big Bang. But you're also connected through consciousness, through your ability to perceive and contemplate the cosmos. You're a bridge between the earth and the sky, between the local and the cosmic, between matter and meaning. The act of wondering about cosmic connections changes you. Your brain physically reorganizes as you contemplate these ideas, forming new neural pathways, strengthening some connections and weakening others. You're not the same person you were when we began this journey together. The universe has literally restructured itself in the form of your neural connections. This is a small change on the cosmic scale, but it's real, physical, measurable. Through wondering about bridges between stars, you have become a different arrangement of matter and energy, a different pattern in the cosmic web. This change in you might seem insignificant compared to the vast scales we've been discussing, but remember that the universe is made of such small changes. Every star began with tiny variations in density in a molecular cloud. Every galaxy grew from quantum fluctuations in the early universe. Every great discovery began with a single person wondering about something. Small changes propagate, create cascades, build into large-scale transformations. Your contemplation of cosmic bridges might inspire someone else to wonder, to study, to discover. The bridges you imagine might become the bridges future generations discover or create. The question also invites us to reconsider what we mean by knowledge and understanding. We tend to think of knowledge as having answers, but perhaps true knowledge includes being comfortable with questions, with uncertainty, with mystery. The most profound questions might be those that don't have single answers, but instead open up new ways of seeing, new possibilities for understanding. What if every star was connected by invisible bridges? Is such a question. It doesn't demand a yes or no answer, but invites exploration, imagination, contemplation. As you rest here in this space between waking and sleeping, between knowing and wondering, you might feel a sense of peace with the unfinished nature of our cosmic understanding. We don't know if invisible bridges connect every star, but we know that the universe is far more connected than we once imagined, and probably more connected than we currently understand. We don't know if we'll ever travel between stars, but we know that humans have always found ways to cross distances that seemed impossible. We don't know if consciousness exists elsewhere in the universe, but we know that the universe has produced consciousness at least once in us, and what happens once in the universe might happen countless times. The bridges between stars might be made of gravity or dark matter or quantum correlations or something we haven't discovered yet. Or they might be made of imagination, of consciousness, of the universe's tendency to create connections and contemplate itself. They might be physical structures we'll someday detect and map, or they might be metaphors that help us understand the connected nature of existence. Most likely they're both and more. Real connections that operate at multiple levels, physical and conceptual, actual and potential, discovered and undiscovered. What matters is not whether we can prove the bridges exist, but what happens to us when we contemplate them. The search for cosmic connections makes us more aware of the connections in our own lives, the bridges between people, between moments, between thoughts. It makes us more appreciative of the extraordinary fact that we exist at all, that the universe has organized itself into forms capable of wondering about the universe. It makes us more humble, recognizing how little we know, and more ambitious, imagining what we might discover. The night sky will be there tomorrow night and the night after, patient and eternal from our brief human perspective. Though we know the stars are slowly moving, being born and dying, following their own vast cycles, the questions will remain. Are the stars connected? Are we alone? What is our place in the cosmos? These questions have been asked by every generation of humans who looked up at the night sky, and they'll be asked by generations yet to come. Each generation sees a little farther, understands a little more, but the mystery remains, deepening even as our knowledge grows. Perhaps the invisible bridges between stars are like the dark matter we know must exist but can't directly see. Real, physical, influential, but requiring new ways of thinking and observing to understand. Perhaps they're like consciousness itself, undeniably real to those who experience it but difficult to explain in purely physical terms. Perhaps they're like love or beauty or meaning, real in their effects on us, but not reducible to simple material explanations. The bridges might exist in the realm where physics and philosophy meet, where objective reality and subjective experience intertwine, where the universe contemplates itself through conscious beings like us. As this journey comes to its close, as you perhaps feel sleep approaching like a tide, gentle and inevitable, consider that you don't need to hold on to all the ideas we've explored, all the possibilities we've imagined. Let them settle into your unconscious like seeds into soil, where they might germinate in dreams, in unexpected insights, in moments of wonder when you next see the stars. The bridges between stars don't require your belief or understanding to exist. They are or aren't, independent of human consciousness. But human consciousness, your consciousness, is enriched by contemplating them. You are lying or sitting somewhere on Earth, a small planet orbiting an ordinary star in an unremarkable galaxy, yet you are also at the center of your observable universe, the unique point from which you perceive existence. Every star you can see is sending light directly to you, has been sending light to the point in space you now occupy since long before you were born. In this sense, you are connected to every visible star, and they are all connected to each other through you. You are a node in the cosmic network, an intersection point where countless bridges meet. The question, what if every star was connected by invisible bridges, has taken us on a journey through space and time, through physics and philosophy, through the known and the unknown. We haven't found a definitive answer, but we've found something perhaps more valuable, a deeper appreciation for the connected nature of existence, the beauty of unanswered questions, and our own role as conscious parts of the cosmos capable of wondering about the whole. The bridges might be invisible, but our search for them illuminates the universe and ourselves. Tomorrow, when you wake, you might not remember all the details of our journey together. The specific facts about pulsars and dark matter, about the cosmic web and quantum entanglement, might fade like dreams often do. But perhaps something will remain, a feeling of connection, a sense of wonder, a comfort with mystery. Perhaps when you next see the stars, whether tomorrow night or years from now, you'll remember not the answer to our question, but the beauty of the question itself. Perhaps you'll feel the invisible bridges, not with certainty, but with possibility, not with knowledge, but with wonder. And that wonder itself might be the most important bridge of all, the bridge between human consciousness and the cosmos, between the finite and the infinite, between what we know and what we might discover. Wonder keeps us searching, keeps us connected to the mystery of existence, keeps us humble and curious and alive to possibility. In wondering about bridges between stars, we create bridges within ourselves, bridges to others who wonder, bridges to the future where our questions might find new answers or transform into new questions we can't yet imagine. So rest now in the network of night, in the web of connection and mystery that surrounds and includes you. Let the question of invisible bridges between stars be not a puzzle to solve, but a doorway to wonder, not a problem requiring resolution, but a meditation on the nature of existence. You are part of the cosmos, and the cosmos is part of you. Whether the bridges between stars are real or imagined, you are proof that the universe creates connections, that matter organizes itself into forms capable of contemplating matter, that the cosmos builds bridges to itself through consciousness. The stars will continue their slow dance through space, following paths determined by gravity and dark matter, and forces we might not yet understand. The universe will continue its expansion, its evolution from simplicity toward complexity, its journey toward an unknown future, and somewhere in that vast cosmic story, on a small planet orbiting an ordinary star, conscious beings will continue to wonder about connections, about bridges, about their place in the magnificent whole. You are one of those beings, here and now, part of the universe's attempt to understand itself. Sleep is approaching now, that daily journey from consciousness to unconsciousness, from the known world of waking to the mysterious realm of dreams. This too is a bridge, isn't it? A transition from one state to another, a connection between different modes of being. As you cross this bridge into sleep, perhaps you'll dream of stars connected by streams of light, of travelling vast distances without moving, of understanding without words. Or perhaps you'll simply rest, your unconscious mind processing all we've contemplated, finding its own connections, building its own bridges. The question that began our journey remains open, inviting, beautiful in its uncertainty. What if every star was connected by invisible bridges? We haven't answered it, but we've lived with it, explored it, let it transform us. And in the end, perhaps that's what the best questions do. Not demand answers, but invite exploration. Not close possibilities, but open them. Not end wonder, but deepen it. The bridges between stars, visible or invisible, real or imagined, remain a mystery. And in that mystery, in that vast network of possibility and connection, we find our place. Small but significant, brief but part of something eternal, separate but connected, wondering and wondered at, bridging and bridged. Good night, fellow traveller through the cosmic dark. May your dreams be filled with starlight and connection, with bridges both seen and unseen, with the peace that comes from resting in mystery and the joy that comes from wondering at the magnificent universe of which you are an irreplaceable part. The stars will be there when you wake, patient as always, keeping their secrets while sharing their light, connected by bridges we may never fully understand but can always wonder about. And in that wondering, in that gentle contemplation of cosmic connection, we find not answers, but something better. Our place in the infinite network of existence, where every star, every planet, every conscious being is part of the same vast, beautiful, mysterious whole. The invisible bridges between stars stretch on through the darkness, through your dreams, through the future that awaits, carrying light and possibility and wonder from one point of consciousness to another, from one moment to the next, from question to question, from mystery to mystery, forever and always, connecting all things in the vast network of night.